Hi guys, good morning and welcome to the next live session. And in this live session, I'll take one of the free online tutorials again. And the topic for today's session is GraphQL. During previous sessions, I I've taken two certification tracks at Free Code Camp dedicated to backend development and APIs. It was first session, and a D3 library which is used for data visualization. And honestly, I didn't like quality of the free code camp tutorials because there was difference between difficulty of actual lessons, practical lessons, and challenges at the end of each certification. And there were even many topics in the challenges which were not covered in the practical lessons at all. And that's why I decided to change a bit the way I'll learn as a student together with you. And yesterday I created such poll and I asked you which topics should I select for the upcoming live streams. And I made a list of those 5 topics: PostgreSQL, Next.js, GraphQL, Vue.js, and Kubernetes. And you voted, and basically I see that you have interest in all of those topics. But most votes were gained by GraphQL and Kubernetes. And again, today I decided to concentrate my attention on a GraphQL topic, and I'll simply go through online tutorial available at the official site for GraphQL. And probably in the next live session I'll select Kubernetes, or I'll see. One of the students actually proposed me to start with Vue.js, then add PostgreSQL, then transfer REST API to GraphQL, and then deploy it using Kubernetes. Yeah, it's a nice suggestion, but in order to do so, I should learn as a student first all those different topics, and afterwards I will be able to create some sort of end-to-end project that will cover all those technologies. So today's topic is GraphQL, and by the way, you could always check courses which I teach online at my website stashchuk.com, and if you go here to courses, you'll find which courses I teach with links to them. Also, you're able to buy those courses with discounts. Great, so let's get started. So here is graphql.org website, and here I already see that it is possible to describe data like that using those types, using GraphQL. Next, I am able to ask from the client what I want using such structure, project name, GraphQL tagline, and get predictable results from the server. Okay, so let's click on Learn and see which tutorials are available here. I see that, of course, there is documentation, yeah, and there are libraries to help you implement GraphQL in many different languages. Let's check that out. For in-depth learning experience with practical tutorials, see how to GraphQL. Let's check this as well. Check out the free online course, Exploring GraphQL, a query language for API. Let's check that too. So here I can read that the GraphQL is a query language for your API and a server-side runtime for executing queries using type system you define for your data. So GraphQL isn't tied to any specific database, it's nice, or storage engine, and is instead backed by your existing code and data. So GraphQL service is created by defining types and fields on those types, then providing functions for each field on each type. So here is an example of creation of two types. So type query and type user. For example, GraphQL service that tells you what the logged in user is. It's me, and its type is user, which points to another type, I assume, as well as that user's name might look like this. Okay, along with functions for each field on each type, query me and user name, return user get name. So this function returns name of the user. Okay, after GraphQL service is running typically at a URL on a web service, it can receive GraphQL queries to validate and execute. And here is sample query. It is just some sort of object, but it is not JavaScript object notation, and it is not a JavaScript object. It is some sort of other kind of object, yeah? Me and name. Okay, so, and this will produce following JSON result, which will be sent by the server to the client. Me, name, and here is a value for name. Okay, so let me check links which I opened here. Code using GraphQL. There are many tools to help you get started with working with which support GraphQL in all sorts of languages, and I see that it supports a lot of different languages, starting from JavaScript and to Perl and D. And here is an example how to install GraphQL for Node.js, I assume, yeah. Here is example for Apollo server and so on. So let me check this link, the full stack tutorial for GraphQL. And here is step-by-step guide with some videos. Introduction, GraphQL is better than REST, core concepts. And afterwards I will be able to choose favorite technology. And for beginners there are such tutorials as React plus URQL. I assume it is one of the libraries for React, which allows React to interact with GraphQL backend. React plus Apollo. I assume this choice is better than, not better, more popular than React plus URQL and GraphQL Node. Okay, so probably I'll select such tutorial for today. And here is also a course called Exploring GraphQL, a query language for APIs. Learn about GraphQL, an alternative to REST, and practice GraphQL queries in an interactive playground. So I assume that here during this course students do different activities in the interactive playground in the web browser. Estimated 7 weeks, 1-2 hours per week. So in total, maximum 14 hours, right? Self-paced, and it is free. About this course, what you learn. Let me... So, advanced tutorial, more GraphQL concepts. I assume that this course will contain many videos, and I don't want to just watch videos during this live stream, and I want to concentrate actually on some practice activities. That's why probably I'll go on with this tutorial for GraphQL. It actually includes few videos at the beginning about core concepts, and I'll briefly watch them through, and afterwards I see that there are no videos, and there are actually practice activities which I assume I will perform locally on my computer. That's what I actually want to do. I don't want to use any interactive playgrounds. Alright, so let's start here. Start with introduction, and let's watch this first video.
Welcome to the first chapter of How to GraphQL. We're going to start with a basic introduction to give some perspective on this new technology. So what is GraphQL? GraphQL is a new API standard that provides a more efficient, powerful, and flexible alternative to REST. It was developed and open sourced by Facebook and is now maintained by a large community of
I'll increase the speed of the playback a bit in order to
companies and individuals from all
watch those videos a bit faster.
over the world. At its core, GraphQL enables declarative data fetching, where a client can specify exactly what data it needs from an API. Instead of multiple endpoints that return fixed data structures, a GraphQL server only exposes a single endpoint and responds with precisely the data that a client asked for.
So that's the first important difference between REST API and GraphQL. So in REST API, usually you create multiple endpoints which describe different resources, like users, then users, for example, /post, and so on. But here in GraphQL, you require only single endpoint. Okay.
So how does it all work? Most applications today have the need to fetch data that's stored remotely in some database that's accessible over the internet. That's what servers are used for. Whenever a client needs some information that it wants to display to the user, it sends a request to the server. The server is programmed in a way that it can respond to the request by retrieving the appropriate information from the database and then sends it back to the client. Before we dive deeper into the technical details in the next chapter, let's understand a bit of the historic context in which the concept of REST was developed. REST has been a popular way to expose data from a server. When the concept of REST APIs was developed, client applications were relatively simple and the development speed wasn't nearly where it is today. REST thus was a good fit for many applications. However, the API landscape has radically changed over the last couple of years. In particular, there are three factors that have been challenging the way how APIs are designed. Increased mobile usage, low-powered devices, and sloppy networks were the initial reasons why Facebook developed GraphQL. GraphQL minimizes the amount of data that needs to be transferred over the network and thus majorly improves applications operating under these conditions.
I would also add a note here. With REST API, because you have multiple endpoints, usually on the same website or for the same web page, you have to make multiple requests to backend in order to get different pieces of data and afterwards combine them on the backend. It means that you create multiple connections to the backend server and actually waste bandwidth because you download more resources. But in GraphQL, if it has only single endpoint, then all data which is required, for example, for a particular web page on the front end, will be downloaded just in one shift. It means that it will be faster, more efficient, and probably devices with low CPU power will process such responses faster and will render actual web page faster.
The heterogeneous landscape of front-end frameworks and platforms that run client applications make it difficult to build and maintain one API that would fit the requirements of all the different clients. With GraphQL, each client can access precisely the data it needs. Continuous deployment has become a standard for many companies. Rapid iterations and frequent product updates are indispensable. With REST APIs, the way how data is exposed by the server often needs to be modified to account for specific requirements and design changes on the client side. This hinders fast development practices and product iterations. Now that we've got a bit more perspective on the concept of REST, let's go and understand a bit more about the history of GraphQL and how it came to be. Facebook started using GraphQL already in 2012 in their native mobile apps. Interestingly though, GraphQL mostly has been picked up to be used in the context of web technologies and has gained only little traction in the native mobile space. The first time Facebook publicly spoke about GraphQL was at React.js Conf 2015, and shortly after, they announced their plans to open source it. Because Facebook always used to speak about GraphQL in the context of React, it took a while for non-React developers to understand that GraphQL was by no means a technology that was limited to usage with React. In fact, GraphQL is a technology that can be used everywhere where a client communicates with an API. It's interesting to note that other companies like Netflix or Coursera were working on comparable ideas to make API interactions more efficient. Coursera envisioned a similar technology to let a client specify its data requirements, and Netflix even open sourced their solution called Falcor. After GraphQL was open sourced, Coursera completely canceled their own efforts and hopped on the GraphQL train. Today, GraphQL is used in production by lots of different companies such as GitHub, Twitter, Yelp, or Shopify, to name only a few. There are entire conferences dedicated to GraphQL, such as GraphQL Europe or the GraphQL Summit in San Francisco. There are more resources like the GraphQL Radio podcast and GraphQL Weekly newsletter that keep you up to date about everything that's happening in the GraphQL ecosystem. This was it already for the first chapter of How to GraphQL. In the next chapter, we're going to get a bit more technical and discuss why GraphQL is the better REST.
Okay, so that was clear. Some history about GraphQL, and initially it was developed by Facebook and it was proprietary, and in 2015 it was open sourced. And basically here is similar description. I don't want to just read some text, and you see that GraphQL is already utilized by many different companies. Which of these statements is true? GraphQL is a database technology. No, GraphQL was invented by Facebook. Go to next chapter. Let's watch this video as well.
Welcome to the second chapter of How to GraphQL. In this chapter, you'll learn why GraphQL is the better alternative to RESTful APIs. Over the past decade, REST has become the standard for designing web APIs. It does offer some great ideas, such as stateless servers and structured access to resources. REST itself actually is a strict specification of how a server has to expose its data to the clients. However, today almost all APIs are labeled to be RESTful APIs, even if they don't adhere to that specification. REST APIs have shown to be too inflexible to keep up with the rapidly changing requirements on the clients that access them. GraphQL was developed to cope with the need for more flexibility and efficiency in client-server interaction. It solves many of the shortcomings and inefficiencies that developers experience when interacting with REST APIs. To get a better feeling for the differences between GraphQL and REST, let's consider the example of a simple blogging application where we want to show a user's profile screen. On that screen, we want to show the user's first name. We also want to render all the posts that the user has ever created. And finally, we also want to display the last 3 followers, because in our blogging app, it's possible to follow each other to see the news whenever a user publishes a new post. How would we tackle this particular screen with a REST API? In REST, we would typically have 3 different endpoints that would allow us to fetch the required data. The first endpoint is the user's ID endpoint, where we can obtain the information about one particular user that's identified by the ID that we are passing in the URL. Then we would also have a /users/ID/posts endpoint that would return all the posts for a specific user. And finally, we also would have the /users/ID/followers endpoint, and here we would get back all the followers of the user that's identified by the ID that we're passing in the URL.
Okay, let me pause the video here. If you want to achieve such functionality using REST API, you have to create at least 3 different endpoints like you see here in this example. And using first endpoint, you will retrieve actual profile of the single user by its ID in the database. Using second endpoint, you will retrieve posts of that particular user, again by ID of that user. And finally, you have to also send one more request for array of followers of that particular user. And that's where you'll utilize one more endpoint like users, then ID of the user, followers.
So let's walk through the flow that we would need inside the application to fetch all the data that we need to display the user's profile screen. The first step would be to fetch the data about the particular user. Here we would hit the /users/ID endpoint to get information about the user that's identified by a particular ID. The server would respond with all the information that it has currently stored about that user. But notice that at this point, we're not only downloading the user's name that we want to display inside the application, but we're also downloading additional information that at this point in time is not relevant to the application, such as the user's address or the birthday. By downloading this additional data, we're putting weight on the user's data plan with information that's actually not required in the app. This is not a desirable situation.
Actually, that's not fully true. If you need only some fields of particular user, and if you want to use such endpoint as here, then it is possible to add, for example, filters, using query parameters, which will be included in the URL. And the server will utilize those filters in order to pre-filter resulting JSON object, which will be sent to the client. And the server has ability to strip some unnecessary fields. For example, remove address from this object and remove birthday, which are actually not required by end user device in order to display just the name of the user, right? So it is possible to filter results before sending them back to the client.
But now at least we have access to the user's name and can display it on the profile screen. The next step for us is going to be to download all the posts of the user. And for that, we're going to use the /users/ID/posts endpoint that we're hitting with the user's ID. This time, the server returns all the information about the posts of that user that are stored in the database. And notice again that we're downloading a lot of additional information that's not really relevant to the app, because we really only want...
Again, using filtering by query parameters, it is possible to filter some unnecessary fields and send, for example, only titles of the posts to the user and not send comments, content, and so on. Of course, it's not necessary.
Want to display the title of each post. But again, at least we've got access to the post's titles now, so we can render them inside our application. And finally, to implement the last requirement of our profile screen, we have to hit the /users/id/followers endpoint to fetch the followers for the users whose profile screen we're showing. We're sending a GET request to the API again, and the server responds with the information about the followers. And notice again, we're downloading a lot of additional data that we don't actually want to display, and we actually also only want to display the names of the last 3 followers, but there might be hundreds or even thousands of followers associated with that user that we're now also downloading. But again, we can at least render the information inside our app. Now, you could, of course...
Yeah, again, same note, and also you don't have to download all users. It is possible to add just limit query parameter in the query string and ask for specific amount of followers you want to get from the server, for example, 5 followers or 10 followers.
Design your API in the way that it exposes the data in the way that it's more appropriate for that particular profile screen. But this is also not really the ideal way to go. In today's application, you want to be able to iterate quickly on your designs and experiment with different features. If you had to go and adjust the API every time you update the design on the front end, then you're not able to iterate quickly on the product. So how can you solve that same situation with a GraphQL API? With GraphQL, you would only have a single endpoint that would be used by all the different clients that want to retrieve data from the server. So with GraphQL, you would actually only send a single request to the server, and the server would respond with all the information that you need. The way how this works is by sending a post request to the server, where you, in the body of that request, you include a query that describes all the data requirements of the client. So in this case, we're asking for the user with a particular ID, and then we can specify all the data that we want from that user. So we want the name of that user, we want to have the titles of the posts of that user, and we want to have the names of the last 3 followers. When the server receives that query, it will process and resolve it to fetch exactly the data that's specified in the query and read it from the database. It'll then package it up into a JSON object that it just returns to the client. This is what the response will look like.
Let me quickly get back. In GraphQL, instead of having 3 different endpoints like in REST API, there will be just single endpoint, and client will send post request, HTTP post request to such endpoint with such query, which will actually ask for all required data which is needed for a particular web page on the client. So we query for user with specific ID. So here is ID of the user, and we want to get such data as username, user post, which will include only title of each post, and followers. We want to get just 3 last followers, and each follower should have only single key name. Yeah, so that's how a query from the user to the server looks like if we are using GraphQL instead of REST API.
This returns to the client. This is what the response will look like. So the root field in this JSON object is called data, and that's what's specified in the official GraphQL specification. And then it returns just all the information that you want to display in the user's profile. So exactly what we specified in the query is now going to be returned to the client, and we can use all that information to render it inside our application on the profile screen.
Okay, so server will respond with such JSON object. So now I see that structure of this response is actually JSON, and it will have data key, and it will contain user object with such keys as name, post, and followers. Name is just string, post is array of objects, because actually each post is object, and inside of each post there will be just single field title. So all titles are here. And same applies to followers. There is array of objects, and each object has just a single key name. All right, that's clear.
So now that we have a better understanding of the technical differences between GraphQL and REST, let's move on to discuss a couple of other high-level differences between them and see what other benefits GraphQL has compared to REST. So first, we eliminate the problem of over and underfetching. And these are exactly the problems that we just encountered in our example scenario. So the problem of overfetching means that we're downloading unnecessary data into our application and thus exhausting the user's data plan with information and data that's not required at this particular point in time. The problem of underfetching, on the other hand, means that a specific endpoint doesn't return enough of the right information, so we have to go and send multiple requests. And this could go and escalate into the n+1 requests problem, which means that we have a list of items that we fetch from the server, but for each of these items, we need more information that we get from a dedicated endpoint. So we actually have to send one additional request for each item that we downloaded initially just to get that information. One way how we could have solved the problem of underfetching in our information.
Yeah, actually,
one way how we could have solved the problem
let me get back quickly. It is clear what is overfetching. It was described before. Overfetching happens when server sends more data to the client than client actually needs. Underfetching when the server sends less information to the client, and client has to send one more request to the server or several additional requests. I could give here an example with REST API where there is needed to display different pages on the client side. For example, page 1 with some product cards, let's say, and when client wants to get few pages of the products and display them just on a single page, client will have to send probably several, let's say 3 requests to the backend API, if it is REST API, asking for different products for specific page, using, for example, page query parameter. But yeah, it is probably underfetching. I don't know whether this example works here. But I assume that in GraphQL it is possible to do everything just in single request, asking for a specific amount of products. So let's go on.
We need more information that we get from a dedicated endpoint. So we actually have to send one additional request for each item that we downloaded initially just to get that information. One way how we could have solved the problem of underfetching in our previous example would have been by exposing an API endpoint that returns exactly the data that was needed for the profile screen. This is a common pattern in REST APIs to structure the endpoints according to the views that you have inside your application. This is handy since it allows for the client to get all required information for a particular view by simply accessing the corresponding endpoint. The major drawback of this approach, though, is that it doesn't allow for rapid product iterations on the front end. With every change that is made to the UI, there is a high risk that now there is more or less data required than before. Consequently, the backend needs to be adjusted as well to account for the new data needs. This kills productivity and notably slows down the ability to incorporate user feedback into a product. With GraphQL, this problem just doesn't exist anymore. Thanks to the flexible nature of GraphQL, changes on the client side can be made without any extra work on the server. This enables faster feedback cycles and product iterations. GraphQL allows to have fine-grained...
Let me get back to this point. Yeah, that's actually true. In REST API, backend developers usually create different endpoints for needs of the clients, of the client devices. And if needs of the clients rapidly change, backend cannot usually keep up with such speed, and some endpoints might be absent for some period, because usually different teams are responsible for development of the front-end applications and back-end applications. And that's why there is a discrepancy of the speed of the development, and that's actually what could lead to delays in deployment of the new features of front-end applications, right? Because again, REST API is usually built for specific needs of the front-end clients.
Faster feedback cycles and product iterations. GraphQL allows to have fine-grained insights about the data that's requested on the backend. As each client specifies exactly what information it's interested in, it is possible to gain a deep understanding of how the available data is being used. This can, for example, help in evolving an API and deprecating specific fields that are not requested by any clients anymore. With GraphQL, you can also do low-level performance monitoring of the requests that are processed by your server. GraphQL uses the concept of so-called resolver functions to collect the data that's requested by a client. Instrumenting and measuring performance of these resolvers provides crucial insights about bottlenecks in your system. Another major benefit of GraphQL is its type system. GraphQL uses the strong type system to define the capabilities of an API. All the types that are exposed in an API are written down in a schema using the GraphQL schema definition language. This schema also serves as the contract between the client and the server to define how a client can access the data. Once the schema is defined, the teams working on the front end and the back end can do their work without further communication, since they both are aware of the definite structure of the data that's sent over the network. Front-end teams can easily test their applications by mocking the required data structures. Once the server is ready, the switch can be flipped for the client apps to load data from the actual API.
Yeah, but in such case, such schema, which is a contract between client and server, as we see here, should be agreed upon creation of the GraphQL API, right? And front-end and back-end teams should plan ahead which schema both sides will be happy with. So that's what should be taken into account at the beginning of the development of actual GraphQL API services.
This was it for the second chapter of How to GraphQL. In the next chapter, we'll introduce the core concepts of GraphQL and talk specifically about GraphQL queries, mutations, subscriptions, and the schema definition language.
Okay, so here is a similar description. GraphQL is the better REST. Data fetching with REST versus GraphQL, so same information as we just saw in the video. So here are three different requests to different endpoints like users ID posts, and users ID followers in order to get all necessary information to show it in the user interface on the end user device. In GraphQL, on the other hand, you'd simply send a single query. So that's sample query, which is sent from the client to the server, and it is sent using HTTP post request. And server responds with such JSON which contains all necessary information according to such query from the client. Of course, it looks much cleaner than such solution with REST API. No more over and under fetching. So client requests only that data which client requires actually. Under fetching, rapid production iterations, of course, yes, because now front end doesn't depend on creation of the new REST API endpoints. Front end application could evolve much faster if, of course, schema for GraphQL was defined with all front end possible requirements in mind. There was also insightful analytics on the backend, which is provided by GraphQL. Schema and type system. Okay, so question, what is the benefit of the GraphQL schema and strong type system? They work well with the JavaScript type system. No, that's not true. It solves the n+1 request problem. Probably not. Once the schema is defined, front-end and backend teams can work independently from one another. Yeah, that's true. Okay, let's go to next chapter. Core concepts.
Welcome to the third chapter of How to GraphQL. In this chapter, you're going to learn about some fundamental language constructs of GraphQL, such as the GraphQL schema, queries, mutations, and subscriptions. In the second part of this video, I will demonstrate how you can experiment with your own GraphQL sandbox environment to apply what you learned in practice. GraphQL has its own type system that's used to define the schema of an API. The syntax for writing schemas is called the schema definition language, or short, SDL. Here's an example how we can use the SDL to define two simple types. One is called person, and the other type is called post. The person type has two fields. They're called name and age, and are of the types string and int. The exclamation point following the type means that this field is required. Post only has one field that's called title and is of type string. It's also possible to express relationships between types. In GraphQL, that's simply called a relation. Let's add a relation between the person and the post types to express that one person can be the author of many posts. We first add the author field to the post type. Now, every post that is created needs to be associated with a person who is the author of it. Next, we add the posts field to the person type to express that a person can write multiple posts. The syntax to specify that something is a list in the SDL is similar to many programming languages. It uses square brackets. Notice that we just defined a one-to-many relationship between the person and the post types. Let's now discuss how you can fetch data from an API by writing GraphQL queries. When working with REST APIs, data is loaded from specific endpoints. Each endpoint has a clearly defined structure of the information that it returns. This means that with REST, the data requirements of a client are effectively encoded in the URL that it connects to. The approach that's...
One moment, it seems to me that my camera is frozen. Let me... Yeah, now it works again. Sorry for that. Let's proceed.
Taken in GraphQL is radically different. Instead of having multiple endpoints that return fixed data structures, GraphQL APIs typically only expose a single endpoint. This works because the structure of the data that's returned is not fixed. Instead, it's completely flexible and lets the client decide what data is actually needed. That also means that the client needs to send more information to the server to express its data needs. This information is called a query. Let's now take a look at an example query that a client could send over to a server. The all persons field that you can see in this query is called the root field of the query. Everything that follows the root field is called the payload of the query. This particular query would return a list of all the persons that are currently stored in the database. Here's an example response. Notice that each person only has the name in the response, but the age is not returned by the server. That's because the name was the only field that was specified in the query's payload. If the client also needed the person's age, all it has to do is slightly adjust the query and include the new field in the query's payload. Now, the server will also include the age of each person in its response. In a GraphQL query, each field can have 0 or more arguments if that is specified in the GraphQL schema. For example, the all persons field could have a last parameter to only return up to a specific number of persons. Here's what a corresponding query would look like. Now the server only returns the last 2 persons that have been stored in the database. One of the major strengths of GraphQL is that it allows for naturally querying nested information. For example, if you wanted to load all the posts that each person has written as additional information, you could simply follow the structure of your types to request this information. So this is what the corresponding query would look like. The server will now resolve this query and include the list of posts that are associated with each person that is being returned. So now we also see that each person has a list of posts in the server response. Next to requesting information from a server, the majority of applications also need some way of making changes to the data that's currently stored in the backend. With GraphQL, these changes are made using so-called mutations. There generally are 3 kinds of mutations. Mutations for creating new data, updating existing data, and deleting existing data. Mutations generally follow the same syntactical structure as queries, but they always need to start with the mutation keyword. Now let's take a look at an example mutation. Notice that similar to the query that we wrote before, the mutation also has a root field. In this case, the root field is called createPerson. We also already learned about the concept of arguments for fields. In this case, the createPerson field takes 2 arguments that specify the new person's name and age. Like with a query, we're also able to specify a payload for a mutation in which we can ask for different properties of the new person object. In our case, we're asking for the name and the age, though that admittedly is not super helpful in our example, since we obviously already know these as we pass them into the mutation. However, being able to also query information when sending mutations can be a very powerful tool that allows to retrieve new information from the server in just a single round trip. The server responds.
So with such a request, we will ask server to create a new person with such fields as name and age with corresponding values for those fields. And also using this part, we query server for new object which was created, new person actually which was created. And we want to get only 2 fields in response, name and age, which will be obviously equal to those values here, which we set in mutation request. So this operation will technically lead to create operation in the database, right? If you know what is CRUD, create, read, update, and delete, then C stands here for create, and that's what we could achieve using such mutation request in GraphQL. And here is a response from the server, create person, and there are 2 keys, name and age.
For the above mutation will look as follows. Notice that exactly as with queries, the server response is shaped according to the mutation that is sent. One pattern that you'll often find is that GraphQL types have unique IDs that are generated by the server. Extending our person type from before, we could add an ID like this. Now, when a person is created, you could directly ask for the ID in the payload of the mutation, since that is information that wasn't available on the client beforehand. Another important requirement for many applications today is to have a real-time connection to the server in order to get immediately informed about important events.
Let me get back to this point. Usually when new records are created in any kind of the databases, specific ID that is unique for a specific collection or database is created for each separate document or record in the database. And that's what does make sense to return back as a result of mutation from the server to the client. So client requests server to create such new person with 2 new keys, name and age, and the server responds back with ID of the newly created person. And afterwards, a client on the client side could perform some other operations with such ID, whichever he needs.
since that is information that wasn't available on the client beforehand. Another important requirement for many applications today is to have a real-time connection to the server in order to get immediately informed about important events. For this use case, GraphQL offers the concept of subscriptions. When a client subscribes to an event, it will initiate and hold a steady connection to the server. In this example, the client subscribes on the server to get informed about new users being created. Whenever that particular event then actually happens, the server pushes the corresponding data to the client. In this example, this is the name and the age of the new user, since that's the information that's specified in the subscription payload. Unlike queries and mutations that follow a typical request-response cycle, subscriptions represent a stream of data sent over to the client. Let's assume there are 3 persons that are created by other clients while the subscription is active. The server would then, for each of these persons, push the corresponding data to the subscribed client. Now that you have a basic understanding of what queries, mutations, and subscriptions look like,
yeah, this feature is very interesting in my opinion, because now clients could get a new data in the real time. For example, when new persons are created by other clients in the database, then the server might send those updates to the subscribed front-end devices. And in each such pushed notification, there will be name and age for each new person which was created. And using such subscription, it is possible to update in the real time front-end web page, for example, and add new posts or add new comments without page reload. So it's a really nice feature. Let's proceed.
each of these persons push the corresponding data to the subscribed client. Now that you have a basic understanding of what queries, mutations, and subscriptions look like, let's put it all together and learn how you can write a schema that would allow to execute the examples you've seen so far. The schema is one of the most important concepts when working with a GraphQL API. It specifies the capabilities of the API and defines how clients can fetch and update data. It is often seen as a contract between the server and the client, and in general, a schema is simply a collection of GraphQL types. However, each schema will have some root types that define the entry points for the API. These root types are the query, the mutation, and the subscription types. Let's now see how we would have to define these types in the schema to enable all the examples that we saw before. First, to enable the all-persons query that we used in the beginning, we need to add a corresponding field to the query type. Notice that we are also adding the last parameter that we were using at some point to limit the number of users that we wanted to retrieve. The type of the all-persons field is a list of persons, since this is what the query will return. Similarly, for the mutation to create a new person, we have to add the createPerson field to the mutation type, since that was the root field that we used when we were sending the mutation. It takes the name and age arguments that we already used before. Notice that the return type of the createPerson mutation, the createPerson field, is a single person object. Logically, this is the one that was created by the mutation. Finally, the subscription type is pretty straightforward. The root field that we used to subscribe to the event of new persons being created was called newPerson. Consequently, this field needs to be added to the subscription type in our schema. The type of the newPerson field is person. Let's put it all together. Here we see the full.
So here we create type person, and in this type we define such fields as ID, name, age, and pose. And the pose are actually arrays of pose, where a post is separate type defined here. So that's the type for post, and each post has title and author, and the author has actually type of person. So in the author field there has to be an object with 4 fields: ID, name, age, and pose. Or what, if I understand that correctly? Okay, and there are also 3 different types query. Those are called root types, right? Query, mutation, and subscription. And inside of them there are all persons, create person, and new person. And for example, all persons has a type array of persons. I don't understand at the moment what this question exclamation mark here means, but probably later it will be explained.
Full schema that defines all the capabilities of our API. It's based on the model of the person and the post types, and then we also define the 3 root types that we just discussed. It is important to realize that despite having defined the post type in the schema, the API actually does not allow any operations on it at the moment. All we can do with the API right now is to read the list of all persons, create new persons, and subscribe to the event of new persons being created. So the post type at the moment is kind of useless. A more realistic and complete version of the schema would define additional operations for both model types. We could, for example, define a CRUD style API by adding a couple of new fields to the schema's root types. CRUD is short for create, read, update, delete, and refers to the 4 kinds of operations we want to be able to perform on a type. The first thing we would have to do is add another field to the query type to retrieve all the stored posts from the server. This field is called allPosts and looks very similar to the allPersons field that we already have in the schema. Notice that with this setup, all we can do is ask for all the posts and all the persons that are currently stored in the backend, but it's not possible to query individual posts or person objects. Next, we can go and complete the CRUD API for the person type. We can do so by adding 2 more mutations, one for updating and one for deleting person objects. The update person mutation takes an ID that allows to specify which person should be updated, as well as the person's properties as arguments. The delete person mutation, on the other hand, only takes an ID to tell the server which person it should delete. This completes the CRUD operations for the person type. Let's do the same for the post type. All we do is adding the create, update, and delete mutations for the post type, analogous to how we specified them for the person type. Notice that we also need to add an ID to the post type for the create and delete mutations to work. Finally, to complete the setup, we're also adding the ability for clients to subscribe to all these events on the person and on the post types that we just created. This is a more realistic setup of an API that defines useful capabilities. Notice, however, that the way how we define the schema still has a couple of flaws. For example, at the moment, it's not really possible to set and modify the relation between person and post. We will leave this as an exercise to you to think about what the corresponding mutations would look like. In general, however, this whole schema already does illustrate the general ideas you need to follow when writing a GraphQL schema. Before we close this chapter, I want to quickly demonstrate to you how you can try out these queries and mutations directly on the How to GraphQL website. When you're going through the written GraphQL basics chapter, you'll find that a couple of code snippets have this Run in Sandbox button right here. When you click this button, we'll generate your own GraphQL sandbox that you can use to try out the API that we just explained in the slides. Once the sandbox was generated, you can go and send the query that's written on the left side by clicking this play button in the middle. This returns the data that was prepared for you in your GraphQL sandbox. If you want to see what kind of data is currently stored in your sandbox, you can simply click the Data tab and you'll get an overview of the persons and the posts that are currently in your database. Of course, you can also send mutations to add, update, or delete data. In the playground, you just have to add a mutation, for example, the one that you saw on the slide before, and click the play button again. And on the right side, again, you'll see the server response. And when you click on the Data tab now, you'll see the new person added to your sandbox environment. This is it for the 3rd chapter of How to GraphQL. In the next chapter, we'll discuss the big picture and highlight some major architectural components that you'll find in all GraphQL infrastructures.
Yeah, so this video was a bit overwhelming because there were a lot of different concepts like specific syntax for creation of the types and schemas. So SDL is schema definition language. So here is an example how we can use SDL to define a simple type called person, which has 2 fields, name and age. This type has 2 fields, they are called name and age, and the types for those fields are string and integer, respectively. The exclamation mark following the type means that this field is required. Okay. So this exclamation mark means that field is required. It's also possible to express relationships between types. In the example of a blogging application, a person could be associated with a post. So here is separate type for posts, which has 2 different fields, title and author, with corresponding types string and person, and both title and author are required. Probably such value here means association between person and post. Okay, we'll see later. Conversely, the other end of the relationship needs to be placed on the person type. Yeah, that's the opposite side of the relationship between person and post, because person could have multiple posts. Yeah, and here we see type array of posts, and that is required. So it is required to have an array here inside of the posts field, and also inside of this array it is required to have at least 1 post, or what? Or maybe empty array is acceptable, should be acceptable. Note that we just created a one-to-many relationship between person and post, since post field on the person is actually an array of posts. Yeah, that's true, because let me quickly draw it. Because actually, if there is a person, so person, probably let me draw it in single color. Person, And the person could have multiple posts, right? So here is first post, second, third. And yeah, that's a relationship which is called one-to-many. Post 1, post 2, post 3. Post 3. So each person might have multiple posts associated with it, and that's a relationship which is called one-to-many. One-to-many. And the single post, on the other hand, is associated only with single person. Right? Okay, let's proceed. Fetching data with queries. When working with REST APIs, data is loaded from specific endpoints. That's what we already discussed before. This means that the data requirements of the client are effectively encoded in the URL that it connects to. Right. So in the REST API, client specifies what it needs in actual URL using actual path in the URL and query parameters if they are present. In GraphQL, this approach is radically different. There is a single endpoint, and a request from the client to the server, which includes all data needs of the client, is called query. Note, unfortunately, we no longer provide the run in sandbox feature that is demonstrated in the video. So we are not able to run in sandbox a specific query. Okay, so let's take a look at an example query that the client could send to a server. So here is query. We query for all persons, and we want to get name for each person. And as a response from the server, we get a JSON object with single key all persons, and its value is array of objects, and each object has single key name with corresponding values. Okay, notice that each person only has a name in the response, but the age isn't returned by the server. That's what we heard in the video. That's how we could query for name and age for each person. Also, we could add posts in the query as well, and in such a way we could request which fields should be present in each post. And posts in the response will be actually an array of posts, and each object in such array will have only single key title. Queries with arguments. So here is argument. We want to get only 2 last persons created in the database. Writing data with mutations, creating new data, updating existing data, deleting existing data. So mutation, create person, and such mutation will create new person, and here are values which will be utilized for filling name and age fields for this particular person. And using such syntax, we request server to return updated, actually not updated, created person with 2 fields, name and age. But in this example it doesn't make sense because we already know on the client side which name and age we send in the request. It does make sense to request ID of the newly created person. Notice that similar to the query we wrote before, the mutation also has a root field. In this case it is called create person. Okay, so this is a root field in this mutation request. We also are able to specify a payload for a mutation in which we can ask for different properties of the new person object. Yeah, that's what we did here on those 2 lines. And the server response for the above mutation would look as follows: create person, and its value is an object with two keys, name and age, with corresponding values Bob and 36, which are obviously equal to those values here, which were sent in the mutation request from the client. One pattern you'll often find is that GraphQL types have unique IDs that are generated by the server when new objects are created. And that's true, and usually it depends on the database, and the method of the generation of such IDs is different for different databases. Extending our person type from before, we could add an ID like this. So that's how we specify one more field in the type person, and its type is ID. But I don't know how this type is actually represented in the database. So probably it depends on the database. But yeah, there is such type as simply ID to uppercase letters. Yeah, hi guys. Now when a new person is created, you could directly ask for the ID in the payload of the mutation, and that's what does make sense. When we ask server to create new person, we expect to get some new information from the server, and that new information is usually ID of the person which was just created on the server side. Real-time updates with subscriptions, and that's what I find really, really useful. So there is a subscription, concept of subscriptions. Using subscriptions, client will hold steady connection to the server. And when specific event occurs on the server pushes corresponding data to the client. Unlike queries and mutations that follow a typical request-response cycle, subscriptions represent a stream of data sent over to the client. So each time when a new person is created on the server, server pushes those persons, which will contain only two fields, name and age, to the clients which subscribed to this information. So here's an example of subscription that comes from the client to the server. After a client sent this subscription to a server, connection is opened between them. Then whenever a new mutation is performed that creates new person, that server sends the information about this person over to the client. So here is an example of the new person object which is pushed by the server to the client if client is subscribed. Defining schema. The schema is one of the most important concepts when working with the GraphQL API. It specifies capabilities of the API and defines how clients can request the data. It is often seen as a contract between server and client. Generally, a schema is simply a collection of GraphQL types. So there are three root types which are predefined, I assume, and those types are query, mutation, and subscription. And I assume that with type mutation, it is possible not just to create new records, but it is also possible to update and delete records, if I understood correctly. So the query, mutation, and subscription types are the entry points for the requests sent by the client. Type query, all persons, person. So to enable all persons query that we saw before. Okay, so in order to allow clients send such kind of such kind of query and process it and send response, on the server side we have to define corresponding schema, right? And here is schema defined for that case. It has type query, and inside of it there is all persons, and its value is array of persons. In such case, we allow clients to send query requests for all persons. Otherwise, such requests will be rejected, I assume, if there is no such schema. Okay, so all persons is called a root field of the API. All persons is root field. If we want also to enable a query for last n persons in the database, then we have to modify this type query in following way. Add also last here in parentheses, and this value will be integer, which is number of last objects in last documents, how to call them, of persons. Similarly, for the create person mutation, we'll have to add a root field to the mutation type. So we add a root field called create person to the mutation type, which is, recap, is predefined. So mutation, query, and subscription are three predefined types. Probably there are also other types. And here we add root field to such mutation with such with name and age fields in parentheses, and it will technically mean that those two fields are required in create person request from the client. So if client wants to create a new person, it has to specify name and age in mutation request. Notice that this root field takes two arguments as well. So here are two actually arguments. And those will be fields of the new person object. Finally, for the subscriptions, we'd have to add the new person root field. Type subscription, new person, person. Yeah, this will technically allow subscriptions from the clients, which will wait for updates regarding creation of the new person records. Putting it all together, this is a full schema for all the queries and mutation that you have seen in this chapter. So here are three root types: query, mutation, subscription. They have root fields such as all persons and all posts in the query type. Those are root fields. Here we allow to query for n last persons or n last posts, and the result is array of persons or array of posts. And it means probably that in single request we are able to query simultaneously for n persons and n posts, not bound to specific person, if I understand correctly. Type mutation. In this type there are three root fields: create person, update person, and delete person. So inside of just single type, which is called mutation, we perform all sorts of create, update, and delete operations. So three letters in the CRUD acronym. And the read operation is performed using query type. So in the mutation type there are three root fields: create person, update person, and delete person. For create person we expect two fields from the client. There are two arguments, name and age, which are both required, and we create new record of type person. In update person we require from the client ID of the person which client wants to update, name and age. So name and age will be new name and age for updated person. Yeah, that does make sense. When we want to perform update operation, we have to specify which exact document we want to update. And if ID is unique field, then of course we could utilize it in order to find corresponding person. Delete person expects only single field, it is ID. Yeah, and it's enough to delete person. So delete by ID. So delete person is root field in this root type mutation. Type subscription, new person. We allow clients to subscribe only for new persons. if there are new posts, it is not possible to subscribe for those new posts. So only updates for persons are allowed to be subscribed to. Type person. In this type there are 4 fields: ID, name, age, and post. And type post with 2 fields: title and author. And in such a way we create one-to-many relationship between person and post. Multiple posts could be bound to single person. Okay, I think that the core concepts are clear to me. What are GraphQL subscriptions used for? Event-based real-time functionality, schema-based, yeah, probably event-based real-time functionality. Yeah, that was correct. Let's proceed to the next chapter. So here is again a video. Let's quickly watch it. Big picture architecture.
Welcome to the 4th chapter of How to GraphQL. In this chapter, we'll discuss some architectural use cases for GraphQL, as well as some major components that you'll find in all GraphQL infrastructures. One thing to note in the beginning is that GraphQL itself has only been released as a specification. This means that GraphQL is in fact not more than a long document that describes in detail how a GraphQL server has to behave, meaning what kinds of requests it should accept and what the response format for these requests has to look like. You can read the specification under the URL that's displayed on the bottom of this slide. If you want to use GraphQL in a project, you'll have to go and build the GraphQL server yourself. You can do that in any programming language of your choice, and you can use one of the available reference implementations for it. But you can also use a service like GraphQL that provides a powerful GraphQL server out of the box. We will now walk you through 3 common architectural use cases for GraphQL. The first one is a GraphQL server with a connected database. This is quite a simple setup that we'll discuss in the next section. Then we have a GraphQL server that is a thin layer in front of a number of third-party or legacy systems and integrates these systems through a single GraphQL API. The third is a hybrid approach of a connected database and third-party or legacy systems that can all be accessed through the same GraphQL API. All these 3 architectures represent major use cases of GraphQL and demonstrate the flexibility in terms of the context where GraphQL can be used. Let's first talk about the use case of a GraphQL server with a connected database. This architecture will be the most common for greenfield projects. In the setup, you have a single web server that implements the GraphQL specification. When a query arrives at the GraphQL server, the server reads the query's payload and fetches the required information from the database. This is called resolving the query. It then constructs the response object as described in the official specification and returns it to the client. Here you see an illustration of this use case where a client is communicating with a single GraphQL server over the web. It's important to note that GraphQL is actually transport layer agnostic. This means it can potentially be used with any available network protocol. So it is definitely possible to implement a GraphQL server based on TCP, WebSockets, or any other transport. GraphQL also doesn't care about the database or the format that is used to store the data. You could use a SQL database like AWS Aurora or a NoSQL database like MongoDB. Another major use case for GraphQL is the integration of multiple existing systems behind a single coherent GraphQL API. This is particularly compelling for companies with legacy infrastructures and many different APIs that have grown over the years and now impose a high maintenance burden. One major problem with these kinds of legacy systems is that they make it practically impossible to build innovative products that need access to multiple systems. In that context, GraphQL can be used to unify these existing systems and hide their complexity behind a nice GraphQL API. This way, new client applications can be developed that simply talk to the GraphQL server to fetch the data they need. The server is then responsible to make sure it fetches the data from the existing systems and packages it up in the GraphQL response format. Just like in the previous architecture where the GraphQL server didn't care about the database being used, this time it doesn't care about the data sources that it needs to fetch the data that's needed to resolve a query. Here we see the illustration of such a system where the GraphQL server acts as the integration layer for legacy systems, existing microservices, and third-party APIs. And finally, it's also possible to combine the 2 approaches and build a GraphQL server that has a connected database but still talks to legacy or third-party systems. In this architecture, when a query is received by the server will resolve it and either retrieve the required data from the connected database or from the integrated APIs. But how do we actually gain this flexibility with GraphQL? How is it that it's such a great fit for these very different kinds of use cases? The key to understanding how GraphQL is able to cope with all different kinds of use cases.
Let me get back to this point. So it is possible to integrate GraphQL into existing solution using connected database, which is actually a database which is directly connected to GraphQL. And I assume this is the most simple way of introduction of the GraphQL into existing system. Or it is possible to place it between clients and third-party APIs or between clients and legacy systems and microservices. And in such a way, we will technically unify access to all resources to the clients. So GraphQL will be single entry point for all requests from the clients. Okay.
Flexibility with GraphQL. How is it that it's such a great fit for these very different kinds of use cases? The key to understanding how GraphQL is able to cope with all these different environments is the concept of a resolver function. As you learned in the previous chapter, the payload of a GraphQL query or mutation consists of a set of fields. In the GraphQL server implementation, each of these fields actually corresponds to exactly one function that's called a resolver. The sole purpose of a resolver function is to fetch the data for its corresponding field. Let's now consider the example of a query that is sent to a GraphQL server and think about the resolver functions that are required to properly respond to that query. Here, we send a query to ask for the user that's identified by a particular ID. In the payload of the query, we specify the information that we'd like to have returned by the server. In our case, that's the user's name, as well as their first 5 friends, of which we are requesting the name as well as the age. The first resolver that would have to be implemented is for the root field of the query. In that case, that is the user field. The resolver function for the user field takes a required ID as an argument and potentially returns a user instance. The return type is nullable since we don't know that the user with the provided ID actually exists. Notice that the function signatures are just pseudocode. To illustrate the idea behind resolver functions, the actual function signatures of your resolvers that you write for your GraphQL server implementation might differ depending on your context. We then can add a resolver function for the name field. Name is a field on the user type and doesn't take any external arguments that can be provided in a query. However, in order to be able to find the name of a user, the server needs to know which user that is. The resolver function thus takes a user as an implicit argument. The return type of this resolver is a non-nullable string, which corresponds to the type of the name field in the GraphQL schema. Next, we can add the resolver function for the age field. That's analogous to the name field, except that it returns an int instead of a string. And finally, the friends field in the query payload can be resolved by a corresponding function that takes an optional parameter called first that can be provided in a query, as well as the implicit user argument, since friends also is a field on the user type, and the server needs to know whose friends it should fetch. This function returns a list of users. The last concept that we'll cover in this chapter is the concept of a graph function.
Okay, so this is important. In order to prepare actual data on the server and send it to the client, we have to implement a certain amount of resolvers, and each resolver is actually a function. And in order to satisfy such query, we have to implement 4 resolvers, because we query for user with specific name and specific friends. And that's actually where I see some sort of complexity, of course, because on the client side it is easier than with REST API, but somewhere else it should be more difficult to implement. So just for such simple query, we have to implement 4 different resolvers. So first one will take ID as argument here, and it is string, and it will resolve to specific user. There is no question exclamation mark here, because user might be absent, and if I heard correctly, it is called nullable type. It means that such resolver might return null as a result of the operation, or user, null or user. Next resolver resolves name of the user, and here as argument it accepts user, which we got as a result of the previous resolver, and it returns as string. And this is required. So if a user is present, then it must have name field, which we specified in the user type actually. So this field is required. Same applies to age. Same resolver. Using such resolver, we could resolve age of particular user. And such resolver returns integer. And there is one more resolver which resolves array of friends. And as argument it takes... What is first? First is quantity of the friends. It is integer and it is not required. It might be present or absent, but user is required. So we are looking for friends of particular user, and such resolver returns array of users. So 4 resolvers in order to satisfy such a relatively simple, I could say, query.
Returns a list of users. The last concept that we'll cover in this chapter is the concept of a GraphQL client. GraphQL is a particularly great technology for front-end developers, since it completely eliminates many of the inconveniences and shortcomings that are experienced with REST APIs, such as over- and underfetching. Complexity is pushed to the server side, where powerful machines can take care of the heavy computation work. The client doesn't have to know where the data that it fetches is actually coming from, and can use a single coherent and flexible API. This provides an opportunity to build new abstractions on the front end to make it even easier for developers to interact with an API. Let's consider the major change that's introduced with GraphQL in going from a rather imperative data fetching approach to a purely declarative one. When fetching data from a REST API, most applications will have to go through the following steps. First, they have to construct and send the HTTP request, for example using the fetch function in JavaScript. Then they have to receive and parse the server response. The data that they parse out of the response has to be stored locally, either simply in memory or maybe persisted. And finally, the data can be displayed in the UI. With the ideal declarative data fetching approach, on the other hand, a client shouldn't be doing more than the following two steps. First, it has to describe its data requirements, and then it can display the information in the UI. Everything that's in between should be handled by the GraphQL client. All the lower-level networking tasks, as well as storing the data, should be abstracted away, and the declaration of data dependencies should be the dominant part in the data fetching process. This is precisely what GraphQL client libraries like Relay or Apollo will enable you to do. They provide the abstraction that you need to be able to focus on the important parts of your application, rather than having to deal with the repetitive implementation of infrastructure and data fetching logic. This was it for the fourth chapter of How to GraphQL. You're now done with learning about the fundamentals.
Let me get back to this point. So in declarative data fetching, a client should not care about storing of the data and actual fetching of the data, which is a normal process in REST API. So in declarative data fetching, client describes only data requirements and displays information in the user interface. So there is some level of abstraction, yeah? It is easier for client to get the necessary data and just display it in the user interface.
Data fetching logic.
That's it for this video.
This was it for the fourth chapter of How to GraphQL. You're now done with learning about the fundamentals of GraphQL and can choose whether you want to continue learning about more advanced GraphQL concepts or get your hands dirty and start coding with a hands-on tutorial with the programming language and framework of your choice.
Okay. So let's quickly summarize. There are three different kinds of architectures that include in GraphQL server. GraphQL server with connected database, GraphQL server that is thin layer in front of a number of third-party or legacy systems and integrates them through a single GraphQL API. And now GraphQL will be single point of entry for all clients. Hybrid approach of a connected database and third-party or legacy systems that can be all accessed through the same GraphQL API. You could combine connected database and third-party or legacy systems just in one solution. So these were three major use cases of GraphQL. GraphQL server with a connected database. So in such setup, if there is connected database, there is just single web server that implements the GraphQL specification, and it is the most easy solution, probably just to play around with GraphQL. The server reads query payload and fetches the required information from the database. This is called resolving the query. It then constructs a response object as described in the official specification and returns it to the client. It's important to note that GraphQL is transport layer agnostic, so it is potentially possible to implement GraphQL server based on TCP, WebSockets, and so on. GraphQL also doesn't care about the database or the format that is used to store the data. You could use a SQL database or NoSQL database. GraphQL layer that integrates existing systems. So it is described how you could integrate legacy systems or microservices and third-party APIs. Hybrid approach with connected database and legacy or third-party APIs. Resolver functions, we talked about them in details. I don't want to repeat that. So this description of imperative and declarative data fetching approach. So with REST API, client constructs and sends HTTP request, receives and parses server response, stores data locally, and displays data in the UI. In declarative data fetching approach, client shouldn't be doing more than just two following steps: describe data requirements and display data in UI. Okay, what is a resolver function? A function that the GraphQL client used to resolve query on the front end. That's not correct. It is performed on the server. It is synonym for serverless function, not a function that solves all your problems. A function in the GraphQL server that's responsible for fetching the data for a single field. Yeah, that's true. Okay. So there is bonus chapter, but I'll probably skip this bonus chapter because I assume it includes some additional theory about GraphQL and GraphQL concepts. That's why let's choose write tutorial, go to next chapter, and yeah, here are few tutorials: React and Apollo, GraphQL Node, and React and URQL. URQL. All tutorials will start from scratch and teach you how to build fully fledged Hacker News clone. Let's have a look at the Hacker News. So here is Hacker News. Just simply list of news, and each news has what is that? Has quantity of points, when posted, comments, quantity of the comments. Okay, so let's choose React and Apollo, probably. Continue with React and Apollo tutorial. React plus Apollo tutorial, introduction. The final project for this tutorial can be found on GitHub. You can always use it as a reference whenever you get lost throughout the course. Okay, in the previous tutorials we covered the major concepts and benefits of GraphQL. Now it's time to get our hands dirty and start out with the actual project. So, this project has such features as display list of links, search the list of links, handle user authentication, allow authenticated users to create new links, allow authenticated users to upvote links, one vote per link and user, real-time updates when other users upvote a link or create new one. And in this track we will utilize such technologies as React, its library for building user interfaces for front end, Apollo Client 3.2, which is caching GraphQL client for React, which will be utilized in the front end. On the back end, we will utilize Apollo Server, fully featured GraphQL server with focus on easy setup, performance, and great developer experience, and Prisma, open source database toolkit that makes it simple to work with relational databases. We'll create the React project with Create React App, a popular command line tool that gives us a blank project with all required build configuration already set up. Yeah, so it's very easy to create new React application using Create React App. Why GraphQL client? In the client section, in the GraphQL part, we already covered the responsibilities of the GraphQL client on a higher level. We actually skipped this section. But a client, of course, is required in order to interact with server, right? In order to speak with server using GraphQL language. In short, we should use GraphQL client for tasks that are repetitive and agnostic to the app we are building. So app itself should not focus on such routine tasks as request for data and so on. So that's the responsibility of the GraphQL client. So responsibility of the GraphQL client, for example, is to send queries and mutations, right? Queries and mutations without having to worry about lower level networking details or maintaining a local cache. This is functionality we'll want in any front-end application that's talking to a GraphQL server. Why build these features yourself when we can use one of the amazing GraphQL clients out there? Yeah, that's true. There is no need to build such functionality ourselves if there are clients. There are several GraphQL client libraries available for every simple use case, such as writing scripts. GraphQL request might already be enough for our needs. What is a GraphQL request? Minimal GraphQL client supporting Node and browsers for scripts or simple apps. Okay. Chances are that you are writing a somewhat larger application where you want to benefit from caching, optimistic UI updates, and other handy features. In these cases, you'll likely want to use a full GraphQL client that handles the life cycle of all your GraphQL operations. So GraphQL request, I assume, is a lightweight client, and such clients as Apollo Client, Relay, and URQL are full-featured clients. Apollo versus Relay versus URQL. So comparison of different GraphQL clients. I will not read all that stuff. So Apollo client is community driven. Right now there is JavaScript client with bindings for popular frameworks like React, Angular, Ember or Vue, as well as early versions of iOS and Android clients. Apollo is production ready and has features like caching, optimistic UI, subscription support and more. Okay, so Apollo client has the most widest support among all those options, and URQL is a more dynamic approach on GraphQL clients and a newer project compared to Relay and Apollo. So this is newer library, and it is highly focused on React, and it focuses on simplicity and extensibility. Okay, so and if it is combined with first-party exchange, it is basically equivalent in functionality with Apollo. Okay, in this tutorial we will use Apollo, right? Let me check one moment. For some reason Google Chrome is taking much CPU resources. Let me I'll reload Google Chrome in just a second. Give me a minute. Okay, now it feels better. So here we will utilize Apollo client. What's the major benefit of using a GraphQL client library? It makes it easy to use animations inside your app. Not true. It saves you from writing infrastructure code for networking and caching. GraphQL client is mainly used to improve security. No. GraphQL clients don't provide actual advantages. So that's the point which is actually true. Okay, let's go to next chapter. Get started. Since this is a front-end track, we are not going to spend any time implementing the backend. Instead, we'll use the server from Node tutorial. Once our React application is created, we'll pull in the required code for the backend. So we will not build backend in this particular tutorial. We will just focus on the front end. Alright, so here is also a link to a final project that is available on GitHub. So, okay, let's go ahead. The first step is to create a React project. As mentioned in the beginning, we'll use Create React App for that. To create new project, run the command below: yarn create React App, Hacker News React Apollo. Let me open up Visual Studio Code. I'll do everything there. Let me simply open up embedded terminal. Here it is. Let me make it larger. And let me cd to desktop. I'll create a new folder here. And let's create a new React app. It seems to me Yarn is installed on my computer. No, it is not available. Let me install it globally. npm install -g yarn. npm. I don't have npm. Okay, let me go to, what about Node? Okay, Let me download Node.js. Let's install Node.js. Okay, let me reopen terminal. Node. Okay, so now Node is available. npm. Let me install Yarn globally, which is actually alternative to npm. Or maybe I'll utilize npx in order to create a new React app. npx create React app. npx. So it is possible to create a new React app using such command npx create React app, and basically create React app package itself will not be installed on my computer in such case. So I don't want to install it globally on my computer. In such case, npx will just download it once from the npm and use it for creation of the new application. And afterwards create React app will gone. So let me use this command, and so let me cd to desktop, and here I'll npx create React app, and the name of the app will be here. It is actually name of the folder which will be now created on the desktop. So let's create new folder, creating new React app in this folder on the desktop. Resolving packages, fetching packages. Such packages as React, React DOM, React scripts will be installed inside of the Hacker News React Apollo folder. What is the next step, by the way? This tutorial uses Yarn for dependency management. Find instructions for how you can install it here. If you prefer using npm, you can just run the equivalent commands. I'll go on with npm. This will create a new directory called Hacker News React Apollo that has all the basic configurations set up. Make sure everything works by navigating into the directory and starting the application. cd Hacker News React Apollo yarn start or npm start. Okay, so resolving the packages. So, project was bootstrapped, and now there is Hacker News React Apollo folder on my desktop, and I could cd to Hacker News React Apollo. And before starting it, let me open it up in the Visual Studio Code. Actually, here it will be opened in the new window. Let me probably go here to File, Open, navigate to Desktop, and select here Hacker News React Apollo folder. It will be opened also in the new window. Okay, no problem. So here is a new window with just bootstrapped project. Let me close welcome page. And it has a package.json file which is present in every front-end React application actually, or backend. Doesn't matter, and it describes dependencies which were installed in this project, and I see such dependencies as React, React DOM, React scripts, and Web Vitals. React scripts is basically main package that was used in order to bootstrap this application. And the version of the React is here, 17.0.2. Let's actually run this project. And in order to run it, you could enter either npm start or yarn start command. So here are actual scripts which you could run start, build, test, and eject. And underlying React scripts executable will be run. So if you enter npm start or yarn start, then such command will be executed. React scripts start. And such executable as React scripts is available in the node modules folder, same as other dependencies. And if you scroll down here to where is React scripts, QR React scripts is here. And also it should be available inside of the .bin folder as executable. So let's scroll down. There are not many executables, and React scripts is executable here. It means that it is available in the application, and it is possible to run it like that: React scripts start or React scripts build. Okay. So before running, let me hide for the moment screen. Okay, let's go ahead and run this project. npm start. Make sure to be in the Hacker News React Apollo folder. npm start. This will start our project in development mode, starting development server. Site cannot be reached. Error address is invalid. So what is an issue here? Okay, let's rerun probably npm start. For some reason it is not running. Network error. Failed to load response data, no resource with a given identifier found. Localhost 3000. Probably let me try 177.27.0.0.1. No, probably something else is running there. But in such case, I would get an error from this script. So now I'm trying to access application using my localhost, not localhost, my IP address of the computer. Okay, so now I accessed it successfully. There is some sort of an issue with my localhost address. I will not spend now time to fix that. So here is a bootstrapped React application, which we just created using create React app. Okay, so let's proceed. And next, what we have to do. So now we see that in the web browser, you should utilize, of course, localhost address, if it works in your case. To improve the project structure, create two directories, both inside of the src folder. The first is called components and will hold all our React components. create a second directory called styles to hold all of the CSS for our project. Okay, so let's in the src create a new folder, components and styles. No, not inside of the component. Styles. So now inside of the src there is components and styles folders. App.js is a component, so move it into components. Now app.js file is located here in the src folder, in the root of the src folder, but technically it is a component. Let me hide this. So technically it is a React component and it is functional component. Here you see function app, and it is exported here as a default. So export default app, and basically inside of this app component, which is main component, there is a header with class name app header, which has image, p tag, edit src app.js and save to reload, and the anchor tag. For example, if I comment out this line, save changes, I will see that there will be no logo anymore, no rotating React logo. That's how you could get rid of this logo if you want to do so. And as you just noticed, there is hot reload feature, and each time when we modify code, those changes will be applied and reflected automatically in your development build. Yeah. So let's move app.js to components folder because it is a component. Now, of course, our application is broken. Let's proceed to next tasks here. So move it to components. You can also move app.test.js there as well, or delete it as we won't use it here. Let's actually delete app.test.js, which holds some default tests for our application. App.css and index.css contain styles, so move them into styles. So let's move app.css to styles and move index.css to styles. We also need to change references to these files in both index.js and app.js files accordingly. So let's go to index.js file, which is still located in the root of the src folder, and here where we import app, now we import it from the local same folder as index.js file, but now we have to import it from components folder like that. And there is app, which is recognized by VS Code, as you might see here. Also, we have to import the index.css file from the styles, and yeah, that's it for this index.js file. And also, we have to modify app.js file. Let's go there, app.js file, and now we have to import app.css file from the styles folder, which is located one level up, styles app.css. So two dots represent parent level, styles app.css. Why do we have to add here one more dot /? It should work like that. Let's try like this. Import logo from svg logo. Now logo is located one level up outside of the components folder. That's why let's access it like that. Save changes. Let's go back to our application. And now it was loaded successfully. It means that now actually index.js file, which contains React DOM render call, which has actually inside our app component, imports this app component from the components folder. Here is a relative path / components app. And now app component is located inside of the components folder here. In the app.js file, we modified those imports, and we import styles / app.css from the styles folder, and also import logo from the folder, which is src folder. Okay, so Now our application is running again. The project structure should now look as follows. So there is src, inside of it there is components folder and styles folder. And that's actually the same structure which I see right now here in my project. Prepare a styling. This tutorial is about the concepts of GraphQL and how we can use it from within a React application. So we want to spend as little time as possible on styling, and I agree with that. To reduce the usage of CSS in this project, we'll use the Tachion's library, which provides a number of CSS classes. And we will load this library using href, and we will add link HTML tag to index.html file, and such file is located in the public folder here, index.html file. There are already few links here, for example, link here or link here. And now let's also add one more link. It will be style sheet, so there is HTML attribute rel for this particular link, and its value is style sheet, and href attribute has such URL in place. It points to CSS file located at unpkg.com. Let me copy that and add a link here, for example, underneath this link. Or probably let me add it here because there is description for this particular link. So I'm not sure whether I have a prettier here. It should auto-format actually this file. So there is link with two attributes rel and href. Great. Since we still want to have a bit more custom styling, we also prepared some styles that need to be included in the project. Open index.css and replace its contents with the following. Let me grab this actually style sheet, go to index.css, and replace its contents with those styles. So there are such styles as body, input gray, orange, background gray, so some colors, F11, W85, button, and these are basically all styles for this particular project. So let's save changes in index.css file. We are done with this, and now we have to install Apollo client. Next, we need to pull in the functionality of Apollo client and its React hooks, which comes in several packages. Yarn add Apollo/client and GraphQL. So we have to install two additional packages. I'll utilize npm command instead of yarn. And I'll open up new terminal window because I'll keep this application running here. So let's open up a new terminal. And here will be npm install, or shortly npm I, and let's install those two packages. Make sure to do that in Hacker News React Apollo folder. So installing. Here's an overview of the packages we installed. So we install Apollo client, which contains all the pieces needed to write up the GraphQL client for our application. It exposes the Apollo client, a provider to wrap around the React app called Apollo provider, custom hooks such as use query, and much more. That's what is actually exported from this package. GraphQL contains Facebook's reference implementation of GraphQL. Apollo client uses some of its functionality within. That's it, we are ready to write some code. Let's check whether we installed those dependencies or not. And yes, it seems that now they are available. So Apollo client is here and GraphQL is here. Wonderful. Let me close all open editors. And let's proceed. So, configure Apollo client. Apollo abstracts away all lower-level networking logic and provides a nice interface to the GraphQL server. In contrast to working with REST APIs, we don't have to deal with constructing our own HTTP requests anymore. Okay, so it will construct HTTP request itself. Instead, we can simply write queries and mutations and send them using an Apollo client instance. The first thing we have to do when using Apollo is configure our Apollo client instance. It needs to know the endpoint of our GraphQL API so it can deal with the network connections. Great. Open src index.js and replace the contents with the following. Let's go to index.js. Here it is. And there are already some imports here. Let's add additional imports. Let's import Apollo provider, Apollo client, create HTTP link and in-memory cache from package called Apollo client. Let me grab that and paste here. Okay, imported. Let's create HTTP link using create HTTP link function, which is imported from the Apollo client. And here as argument we pass an object with single key URI, and here is actual path to, I assume, backend server. Probably in my case I will need again to modify localhost to IP address of my network interface card. We'll see. So let me copy that as it is right now here. So paste. Const client. Here we create new instance of the Apollo client. So Apollo client is a class, and we import this class from Apollo client. And here as argument for initialization we pass link and cache. So link holds HTTP link here, and cache is a new instance of the in-memory cache. Okay, let's paste it here. And now we should modify render method call. And now we will wrap our app component in the Apollo provider. And it has single prop. It is client, and its value will be client, which we just created over here. So instead of react.strict mode, here will be Apollo provider, and here will be closing JS6 tag. By the way, here you see what is called actually JS6. With JS6 you are able to combine HTML syntax and JavaScript syntax. So here in the curly braces is JavaScript expression. Basically here we just put one variable called client. If at the beginning of the JS6 tag there is uppercase letter, then it is assumed that you want to insert component, React component, not a plain HTML tag. But if you want to add, for example, BR tag, you have to write it like that, BR. Or for example, div tag, yeah? So start with lowercase letter, like that. But here you see that they are even highlighted using red color. There are components, app component and Apollo provider component. So app component is placed inside of the Apollo provider component. And Apollo provider component is imported here from the Apollo client. Okay, so we modified index.js file. We imported all dependencies which we need from Apollo client package, which we installed before using npm. We created HTTP link that will connect to our Apollo client instance with a GraphQL, which will connect our Apollo client instance with GraphQL API. So GraphQL server will be running at this URL, as I just told you. So here is different port 4000, but it will be running also locally on our computers. We instantiate Apollo client by passing in the HTTP link and a new instance of the in-memory cache. So here where we create new instance of the Apollo client. Finally, we render the root component of our React application. The app is wrapped with a higher order component. Apollo provider here acts as a high order component, or shortly HOC. And here we pass client as a prop for this higher order component. So Apollo provider will have single property, or prop shortly in the React world, which is client. That's it. We're all set to start for loading some data into our application. Now we have to run backend. By the way, let's save changes and check whether our application is still running here. And yes, it is still running. Now let's download server code. As mentioned above, for the backend in this tutorial, we'll simply use the final project from the Node tutorial. In this terminal, navigate to Hacker News React Apollo directory and run the following commands. So in the Hacker News React Apollo folder, which is already opened here, it is our front-end application, we will add also backend folder, right? So let's do that. Let me copy this URL from here. By the way, if you're on Windows, you may want to install Git CLI to avoid potential problems with commands such as curl, because in the PowerShell on Windows, curl is absent, if I'm not mistaken. Okay, so let me, in the Hacker News React Apollo folder, let me paste this command, curl, and it will point to such URL: code load, github.com, how to GraphQL, React Apollo, tar.jz starter. Then we will unzip contents of the tar archive, strip parent folder, and put everything into the React Apollo starter/server folder. Okay. So now there is a server folder here inside of the Hacker News folder, and it contains such folders as Prisma, SRC, and several files. So server folder is located right here. Wonderful. We now have a new directory called server inside of our project that contains all the code needed for our backend. Before we start the server, let's quickly understand the main concepts. So Prisma is a directory which holds all the files that relate to our Prisma setup. Prisma client is used to access a database in our GraphQL resolvers. Okay, so schema.prisma defines our data model for the project. So where is Prisma? Schema.prisma defines. Let me search marketplace for Prisma files. Prisma. Let's install this extension in order to actually be able to read Prisma files properly. Installing such extension. It was installed. Let's open schema.prisma again, and now it is highlighted with different colors. So data source DB is SQLite. Here is URL to actual database. So all data will be stored in the file dev.db. Let's open it anyway. So here are contents of the dev.db file. This is the most simple version of SQL. So here we create, let's go back to schema.prisma. So here is generator, model link, model user, model vote. Okay, let's don't focus at that for now. So dev.db is a SQLite database that will be used to store and retrieve data for this tutorial. Okay. And basically inside of the schema.prisma there is definition of the database tables and relations between them. So model user, model vote define actual structure of the database. So SRC, in this directory there are source files for our GraphQL server. So here is SRC folder. It's a bit difficult to navigate between server and client because all of them are located in the same folder. So in the SRC there is schema.graphql, which contains our application schema, schema.graphql. So here is schema. I don't see actual, so it is not highlighted. Maybe I should install extension. Let me search for extension GraphQL. GraphQL, let's install it. installing. So package was installed, extension was installed. So now let me go to schema.graphql, and yes, now it looks much better. There are such types as query, feed, mutation, subscription. We are already familiar with such root types as subscription, mutation, and query, and they are all present here in this schema. There are also additional types such as feed, auth payload, which will contain token and user. There is also type user, type link, type vote, type link order by input, and type sort. Enum sort. I don't know what is enum because we haven't covered that before. So, all right. So that's a schema for GraphQL. There is also resolvers folder, which contains resolver functions for the operations defined in the application schema. Where is resolver? So here is resolvers folder, which consists bunch of JavaScript files. Let's have a look at the user.js file. Here is function links with such arguments as parent, args, context, which returns context.prisma.user .find unique, where ID is parent.id .links. Okay, so here we chain two methods of the user. Okay, and export it from the file. Let's have a look at the vote, and the vote has such functions as link and user. Recap that resolver function returns actual data for a specific part of the user query. Find unique, where ID is parent ID. Okay, probably we will get back to it later. So resolvers contains a bunch of resolver functions. Index.js is entry point for our GraphQL server. Where is index.js file? So here it is in the src folder. It's door actually to our backend application, and it will be running. Server is running on URL. Where is actual URL? Let me have a look at package.json file. So scripts start node src/index.js. So we start index.js file located in the src folder, which we just observed. Where is actual URL? Server is running on URL. utils.js. Let's search for URL here. Okay, let's proceed and see how we will actually run our server. From the mentioned files, only the application schema defined in the server src schema.graphql is relevant for you as a front-end developer. And we briefly observed structure of this GraphQL schema. This file contains GraphQL schema, which defines all the operations, queries, mutations, and subscriptions we can send from your front end up. Here is what it looks like. We already observed it here. So it is located in the schema.graphql file in the src folder. Here it is. This schema allows for the following operations. Queries. Feed retrieves all links from the backend. Note that this query also allows for filter, sorting, and pagination arguments. Let's have a look at feed. Type query feed, and it points to feed, so it has type feed here, and we could query for info and feed, and we could apply filtering, skip, take, order by. I assume that take is quantity of the elements we want to, quantity of the records we want to retrieve from the backend. Mutations. In mutations, where is mutation type? In mutation, we allow authenticated users to create a new link. So here is post. Post, and when post is called, when user creates query to post new link, it must provide URL for link and description. Sign up, create an account for a new user. So that's how we create new user, and the client must provide such fields as email, password, and name. Okay. Login an existing user. So here is login, and we accept such fields as email and password, and both are required. And actual password is just string. Our payload here, and vote allows authenticated users to vote for an existing link. So here is vote, and there is single argument link ID user wants to vote for. Great. Subscriptions. Subscription type has new link and new vote, and users could subscribe for new links and new votes for already published links. Subscriptions recap will push updates to subscribed clients. For example, we can send the following feed query to retrieve the first 10 links from the server. Feed, skip 0, take 10, links, description, URL posted by. So that's what is allowed by this query. We are allowed to query feed and specify here skip, take. All of them are optional. So here we don't see exclamation marks. So those fields are optional. By the way, printer actually auto formats this document if I save it like that. Okay. And we actually retrieve first 10 links by using skip argument. And the fields which we want to include in each link are here: description, URL, posted by. And those fields are present in the link type, right? And we see here description, URL, posted by. And posted by type is actually user, and the user has such field as name. That's where it is defined. All right. Or the sign up mutation to create a new user. So mutations are here, and we could send sign up query, mutation query, with mandatory fields email, password, and name. Email, password, and name. And here we define which fields we want to retrieve for newly created user from the server. And those fields will be token and user. And user will have only single field ID. So token will be used for further operations between client and server. So where is user? So here is ID for the user. By the way, user doesn't have token. Where is token here? It is in the type auth payload. And where is auth payload? Auth payload is what is actually returned as a result of sign up query or login query. So we return auth payload, and that's why we are able to ask for token here, because auth payload contains token and user object. Next, creating a database and generated Prisma client. This is one thing left to do before we can start our server and begin sending queries and mutations to it. We need a database and generate Prisma client so that we can actually store and retrieve data. Prisma supports several relational databases, including Postgres, MySQL, and SQLite. For this tutorial, we'll keep things simple and use SQLite, which will store everything just in one file, dev.db, located in the server/Prisma folder. So SQLite is a file system database that is very easy to get started with. It should be noted, however, that SQLite may not be suitable for production purposes. That's true, of course, so don't use it in production. This file is our SQLite database, dev.db. You are free to use Postgres or MySQL for this tutorial if you prefer. All aspects of the tutorial will still work with those databases. But we will go on with SQLite. We need to change directories into server and run some commands to generate Prisma client. Before doing so, make sure to install dependencies. So let's go to server folder. So cd server, and inside of the server folder, let's enter npm install to install all dependencies, because there is also package.json file with all dependencies for our backend application. Next step will be to generate Prisma client using command npx prisma generate. So okay, still installing packages. Let me meanwhile have a look at the package.json file in the server folder. So package.json file, here is list of dependencies, Prisma client, Apollo server, bcrypt.js, which will be utilized for tokens, JSON Web Token, or shortly JWT. Dev dependencies are here, and there are scripts such as start and dev. And the dev will essentially start nodemon process, which will allow us to apply changes on the backend if we make some modifications of the code. So it has library load capabilities. But Node, on the other hand, doesn't have such capabilities. So you are able to enter either npm start or npm run dev to run corresponding script here. So packages were installed. Let's now generate Prisma client using npx. Now I see actually npx command in this tutorial. In other places we've seen yarn command. So let's use this command, npx prisma generate. Okay, generated Prisma client. You can now start using Prisma client in your code. Import Prisma client from prisma/client package. Okay, but what changed basically in the server folder? Server, Prisma, nothing changed here. So it seems to me that Prisma client was created in the node modules folder, and here in the index.js file there is already code which imports Prisma client from the Prisma client. Okay, so Prisma client was generated exploring the server. With Prisma client generated, we can now explore our server. And let's navigate to server directory and run the following commands to start the server. And we will enter command npm run dev instead of yarn dev. We have to execute dev script instead of start. The script first starts the server using nodemon which is then running at this localhost and port 4000, and then opens up a GraphQL playground for us to explore and work with the API. Okay, but where is actual port? Where we define port? Find in folder 4000. Is it some sort of default port for... No, it is not defined in the server folder at all. Okay, probably it is one of the default ports for the server. So let's, so we are already in the server folder. Let's npm run dev. Starting node src/index.js. Server is running on localhost 4000. But let me try to access it. I had issues with localhost for 3000, localhost 4000. So now it was loaded. It is some sort of an issue with port 3000 on my localhost address. So here I see interactive actually server, which allows me to write queries here on the left side, hit the play button to get a response here. Okay, so server is running, and that's what we see right now on my computer. And let's create such request, for example, as I see here, or probably it is just an example. Let's try to create same request as I see here. Feed links ID. Let's write it. So feed links ID, and let's run it. Error, failed to fetch. Please check your connection. Server cannot be reached. Okay. So probably we have to do something else. A playground is a GraphQL IDE, providing an interactive environment that allows to send queries. App crashed for waiting for file changes before starting. So there was an error. Parser initialized const function callback info assertion args to is int 32 failed. Probably we got an error due to empty database or what? Okay, let's go on with this description. So this interactive playground is similar to a tool like Postman, which you might know from working with REST APIs. So using Postman, of course, I'm more than sure that you are familiar with it, and at least you know what it does. So you are able to test REST API endpoints using Postman and get responses. So you could send different sorts of HTTP requests like get, post, delete, and so on. So the first thing to note about the playground is that it has built-in documentation for its GraphQL API. This documentation is generated based on the GraphQL schema and can be opened by clicking the green schema button on the right edge of the playground. And can be opened by clicking the green schema button on the right edge of the playground. Where is schema button? Schema. So here is schema. Okay. Type feed, type link. That's that types which are defined in the server folder here in the schema.graphql file. Here is this file opened. Type mutation, type query, enum sort, type subscription. Okay. Also, there are docs. Let's click on docs. Why I can't change width of it? Let me click on docs again. I cannot drag it. No. For some reason schema is expandable, but docs not. Okay. So there are such queries as string, feed, mutations, subscriptions. Okay, so that's docs step. But why it is not expandable? I don't get it. Aha. So because my server is not running anymore. Because app crashed, npm run dev. But why it crashed? Probably because I utilize one of the latest versions of Node. I don't know. There is no readme for... there is a readme. This repository contains final project for GraphQL JS tutorial. Okay, so server is running again. Let's refresh it. Docs. I still cannot change width of the window. Yeah. Schema. Yeah, very strange. Ah, okay, I have to click on something. So queries, info string, feed, type feed, mutations, post link, type link, ID description, URL posted by, votes, created at. Okay, so let's go on. We explored docs. The left pane of the playground is the editor that you can use to write your queries, mutations, and subscriptions. Once you click the play button in the middle, your request is sent and the server response will be displayed in the results pane on the right. Let's simply click play with empty query. Nothing happens. If I go back to that, server cannot be reached. Please check your connection. And again, server crashed. Let's rerun it. At first, you will create a user. If you have not already, send the following mutation to create a new user. Let's create new user. Probably that will work. So mutation, sign up, name Alice, email, token, user, and name ID will be returned back as a result of that operation. So let's run that. And again, server cannot be reached. Okay, let's try to fix that error. Assertion. Let's take this error from here. Okay. For now, I am downgrading my Node version to 12.18.4 until the bug is fixed. So, okay, I'll have to install another version of Node. That's what I probably expected, yeah? So let me terminate this process. Control C. So now I'm using Node version 16.13.0, and this guy says that version 12.18.4 was used. Probably server is a bit outdated and I have to update server itself. Let me check versions of the dependencies of Prisma client and Apollo server. So what is the last version of Prisma client? Let me check it. npm. So version 3.4.1 is available. It seems to me that the version of this server project is a bit outdated. Do we have maybe more recent version? So, which URL did we use to get server project? So, code load GitHub how to GraphQL React Apollo. Let me go to this URL. Okay, github.com. I don't know what is better, either try to update those packages to latest versions and try to run server, or to use older version of Node. Let me try first to update those versions of the packages, and let me just do following. Let me change version of the Prisma client here, and let me find latest version of Apollo server. Apollo server, and this version is 3.5.0. Let me take it here as well and paste. And now let me reinstall dependencies. Actually, let me delete the node modules folder first. And now let me npm install. So inside of the server folder, I'm reinstalling dependencies, and more recent versions of the Prisma client and Apollo server will be installed. Okay, they were installed. Now let's repeat the same of what we did in order to create Prisma client. We entered creating database. So we don't need to create database because there is already file dev.db, right? Next, let's run database migrations and generate Prisma client. But we don't generate any migrations for the database here in this tutorial. Inside of the Prisma, there is dev.db migrations. Dev.db package.json. Okay, let's first enter this command again in the server folder. Okay. It tells me that it still used the previous version of Prisma. There was also dev dependency. So Prisma client, Prisma CLI is a dev dependency. Let's reinstall this dependency as well and install latest version. Prisma Prisma CLI. Let me check Prisma CLI version. Okay, it seems to me there is no longer Prisma CLI package available, and instead of it there is just Prisma package. So it was renamed. Okay, so let's let's remove node modules folder again. Let's try to install now Prisma package. Let's uninstall this Prisma CLI maybe. Okay, conflicting peer dependency. Let me remove also package dashlog.json file probably. Apollo server. And let me simply type here Prisma, and the version will be 3.4.1. 3.4.1. And now let's npm install. Okay, installed. Let's try again generate Prisma client. Okay, generated Prisma client. But where do we access Prisma CLI? Let me find in folder Prisma CLI. So in the index, we require here Prisma client. So okay, probably we are good to go here. Let's npm run dev in the server folder. App crashed. Okay, new pops up, is not a constructor. Yeah, there were breaking changes, and pops up Apollo server. Okay, Apollo server pub sub is not a constructor. So yeah, this won't work with Apollo version 3. Apollo server 3 removes built-in support for subscriptions. So that's how we could set subscriptions in the recent version. Yeah, there were some breaking changes related to subscriptions, and the best way for me now will be probably to downgrade Node.js and use older version in order to be able to finalize with this tutorial, which is a bit older, yeah, than I expected. So that's why let's actually remove server folder, delete, and I'll clone it again from scratch. So let me cd. I'm now in trash. Okay, so cd desktop Hacker News React Apollo, and here where I'll again clone server folder. You create server folder where with this command. Let me copy it. cd server. Let's npm install here again. npx prisma generate. Let's wait until all dependencies are installed, and meanwhile I have to downgrade Node.js. So npx prisma generate. So client was generated, and now let me install multiple node versions. So nvm version. Do I have nvm? Let me go probably to the terminal and do that here. nvm dash version. Okay, nvm is not available. npm install -g nvm. Let's install nvm globally. nvm dash version. nvm. nvm setup. It is instructions for Windows. Okay, I don't have to install nvm globally. npm uninstall -g nvm. Let's uninstall that package, and now let's see URL. Okay. nvm version. Command not found. Verify installation. nvm list. Let me reopen terminal probably. nvm. Okay, now nvm is available. nvm list. Let's install this version that is mentioned here, 12.18.4. nvm install. Installing 12.18.4. nvm list, and let's nvm. I will not set this as default, but now it should be set and should be selected. No dash version. Yes, now it is here. Now I should check whether it is available here in the VS Code. I have to reopen terminal here as well. Let me delete those terminals here. let me first npm start for front end part. And now let me open up a new terminal and cd to server. Okay. So my front end app should be still running. Yes, it is running now. And now I'm in the server folder, and let's first node -- version. And now I have necessary version of the node. It is a bit older than the recent version. And let's npm run dev in the server folder. Okay, server is running. Here is playground. Here is playground. Let's refresh. Okay, let's run this query. And now I see result. Now everything works perfectly. Great. Let's now continue with the tutorial. So again, this issue happened because in the backend part, there is a bit older version of Prisma packages installed. Okay, so npx prisma generate. Let's also send this query, which I attempted at the beginning. Where is this query? No, it is not here. It is here. Feed links ID. By the way, I have just created new user, right? A new user with name Alice, and ID which was generated is 3. And here is token which was generated for this particular newly created user. So here I see response object which has key data, and inside of it there is sign up, which fully reflects structure of this query. So sign up, inside of it there is a token and user. And user has 2 fields, name and ID. Okay. Let me try also feed links ID. It is just query, yeah? Feed links, and here will be ID. Let's run it. And now I see here just 2 links with IDs 6 and 7. And those links, I assume, were already pre-populated in the SQLite database. So they were already inside of the project. Okay, but which fields links also have other than ID? Let me go to queries feed. Let me go to queries feed. So type feed ID links count. What if I add here count as well? Count. And send request. Okay, I got count of links. Yeah. So because count is field in the field type. Wonderful. So what else I could do with feed? ID. Let's also add ID here. ID main feed. So each ID has its own ID, and in this example, feed has ID main feed. What else here is available? Links. Let's have a look at the type link and see which fields are available there. ID, description, URL, posted by, votes, created at. Let's add also description to our query. So description is string. Yeah, no, let's add URL and posted by. URL and posted by. And let me remove this ID and count from here. Okay, errors. ID, URL, posted by. Field posted by of type user must have a selection of subfields. Did you mean posted by? Okay, so here we have to specify at least one field. For example, name of the user. Let's run query now, and now I got response. So now feed contains links, and each link has, it is actually links is array, and each link is an object which has such fields as ID, URL, and posted by. And now inside of the posted by there is actually user object, and there is single field name, John Doe. That's first link, here it is, which we get using such query request. And here is one more link. Its ID is 7, URL is here, and posted by is the same user as was used here for posting this link. Wonderful. So, yeah, it looks nice. Let's proceed with this tutorial. So what else should we do here? So we already created new user. Let's query for that user. Let's how we could query for user? Are we able to query for user? Info string info. No, we are not able to query for user. We are able just to query for info. But what if I add here info instead of feed? Info. What I'll get? Cannot return null for non-nullable field query. Let me go to server Prisma schema.prisma. No, to src schema.graphql. So here is query, info, and feed. So we are able to query only for links in the feed. And here we are able to post new links, sign up new user, login new user, vote for specific link, but we are not able to query for new user. All right, let's go on. So let's go on. Let's go back to previous query. Feed links ID URL posted by. Okay, so we just created new user. It is Alice. Send the following mutation to create a new user. We already did that. From the server's response, copy the authentication token and open another tab in the playground. I forgot to copy token. That's why let's create a user again, probably. Same user, or maybe I'll create user Bob. Sounds good. Sign up name Bob. And here will be Bob at Prisma.io. Password is GraphQL, okay. And I expect to get token and user name and user ID. So here is token. Let me copy it from here and let me paste it here in Notion. So this token for user Bob and its ID is 4. Great. From the server response, copy authentication token. We already did that. Inside that new tab, open the HTTP headers pane in the bottom left corner and specify authorization header. Let's open up new tab here to this playground and set HTTP headers. HTTP headers. And specify authorization header. Replace the token placeholder in the following snippet with copied token. Let me grab that from here and paste it to HTTP headers, bearer, and here we will put token which we just copied from the response. And I'll take this token from here. Like that. So here is token that comes after the word bearer. But I don't get why here is the space. There should not be any space. But here I see space. Authorization bearer. Authorization bearer format. Authorization bearer and token. There should not be any space before bearer. Authorization bearer. Yeah, let's go on without space. Whenever you are now sending a query mutation from the tab, it will carry the authentication token. This is necessary to perform queries and mutations that require you to be logged in. So we will perform now some operations which require user to be logged in, and token, actually presence of the token in the headers of the HTTP request are indication that user was already logged in. Now you will run two such mutations. Copy the following two mutations into the editor pane. Let me copy. Since you are adding mutations to the editor at once, the mutations need to have operation names. In your case, these are create Prisma link and create Apollo link. Okay, let me do what is requested here. Mutation, create a Prisma link. Mutation, create Prisma link, and mutation, create Apollo link. Post, description, URL, ID. But let's have a look at the mutations here in schema.graphql. Type mutation. Post, sign up, login, and vote. But how we perform the mutation for user? Let me scroll a bit up. So we have created user simply like that, mutation, and without name of the mutation. But now there are names for mutations, and it means that we will send actually two mutations just in one request from the client. So we will create two links. And I assume that those names could be any we want, because they don't match with any names on the server side. So the just indication of uniqueness of specific mutation. So here we want to create two new posts by particular user, and particular user will be defined by the token which is present in the HTTP authorization header. So here is token for user Bob, which we just created. All right. So here are two mutations. Okay, let me take them from here and go to actual playground here, where there is HTTP header. Let me minify that. Let me paste those two mutations, create Prisma link and create Apollo link. Let's run that. Now I can choose which mutation I want to run. I cannot execute two mutations simultaneously just in single request. I have to execute them one by one. So let's do that. So let's run this, create Prisma link. Here is the response. So post has ID 9. That's what I requested here. So I want to get only ID of the newly created post. And if I run second mutation, I'll, as expected, get ID 10. So IDs are incremented one by one. So we created two new posts. This creates two new link records in the database. You can verify that the mutations actually worked by sending the following query in the already open playground. So here is previous playground where we sent such request as this one, feed links ID. Let's now send a request only for IDs and URLs of the links. So let me remove that. So links, ID and URL. Let's run. And now I get 4 links. 2 of those links were already present before. They were created by other user. And those 2 were just created myself. And actually Bob is creator of those 2 links. So with IDs 9 and 10. If I go back to posted by name, I should see here name Bob. Yeah. So name Bob is located in the posted by field here and here for those 2 links. All right. And here are corresponding URLs. Let me post one more URL description. Bogdan's courses. And here will be a link to my website. Okay, mutation, and I'll remove this mutation. And let me execute query. I got ID 11, and if I repeat same query now, I should get one more link here. And here it is. All right, posted by Bob. And if I add here count as well, I should get total count of all links. And now there are 5 links in the database. So 2 were created before and 3 I just created myself. So here they are. Great. It is relatively easy. You can also send the feed query in the default playground in the app. Where is default playground in the app? What does it mean? Okay, let's proceed. If everything went well, the query will return the following data. The IDs will of course be different in your case, since they were generated by Prisma and are globally unique. Let's add here ID, but we already added ID. So and IDs in my case are 6, 7, 9, 10, 11. But format of my IDs is different from this format. And it seems to me that IDs are generated by Prisma for different databases differently. Maybe that is the case. Fantastic, our server works. Okay, I tried enough. Maybe what else I could try? Mutations, post, sign up, log in. Login simulates login of the user, right? And login should generate new token. Let's try that. And let's mutation login. Let's send mutation login. Mutation login. And here we expect to get token for the user which is logging in. And login expects email and password. So let's add here email and the password. And email and password are email and password of the user which we registered actually. Alice, so we created user with a name. Let me use Bob now. So name is Bob and email is bob@prisma.io. Bob at, no, sorry, email is here, bob@prisma.io, and the password is GraphQL, like that. And I want to get token. So this mutation actually simulates user login. When user just opened the page and tries to log in. Let's send request, and I got token. And of course, this token is different from the previous token, which was created before when user was actually registered, when we created new user. So here is new token. And now we could try to create one more post with updated token. So let's go to headers and let's replace this token with new token. Let me grab it from here, paste here. So here is updated token. And now let's send mutation again. And mutation, let's copy from... Let's try, you know what? Let's try to vote for some link. Could I vote? Vote, ID, link, user. But why in the vote I should specify both ID and link? It's not clear to me. ID, link, and user. But what is link? What is link here? Schema GraphQL. Type link, ID, description. Let me have a look at the mutation. Mutation vote. I have to just specify linked ID I want to vote for. But vote, mutations, vote. Aha, that's where I see it. So link ID. And it returns me actually vote. Yeah, it returns me an object of type vote. So I have to specify only link ID. And I know that there is a link, for example, with ID 11. Let's try to vote for this link with ID 11. Mutation, vote. And here we specify only single argument, link ID. And its value is 11. And I want to get in response what? ID of the new vote. Link, user, and user will have user, link, user, and I want to get name of the user which just voted. Recap, I just updated HTTP header, and here is updated token which I got from the server when user has actually logged in, when I simulated user login. So let's vote for this link. Let's send this query. Message field link of type link must have a selection of subfields. Okay, here I have to also add some subfields, for example, URL. I'm voting for. Link ID, vote. Let's execute that. All right, I voted for this link with such URL. That's where I specified that I want to get URL of the link I voted for. And here is the name of the user which created corresponding link. Or no, probably the user which is voting right now, right? And here is ID of the vote which was created in the database. Okay, sounds nice. Let's proceed. Let's proceed. So I completed this page. There are all sorts of other operations that we will perform later. Probably I already performed some of them myself. Okay, so why are there two GraphQL API layers in the backend architecture with Prisma? To increase robustness and stability of the GraphQL server, If one layer fails, the server is backed by the second one. I'm not sure if it is true. Prisma provides the database layer, which offers CRUD operations. The second layer is the application layer for business logic and common workflows, like authentication. To increase performance of the second layer is the application layer. Probably this one is true. To increase performance of the GraphQL server, requests are accelerated by going through multiple layers. Let's check this checkbox. Yeah, that's true. And let's go to the next chapter. Queries, loading links. The first piece of functionality we'll implement in the app is loading and displaying a list of link elements. Oh, I forgot that we have to integrate everything in our front-end application. That's what we'll do throughout those next steps. We'll walk up our way in the React component hierarchy and start with the component that will render a single link. Create a new file called link.js in the components directory. Let's go to components directory in the src folder and let's create new file link.js. Let's take this code, paste here. We import React from React, and here we create functional component using arrow function syntax. So we take a link from props. Basically, we could destructure link immediately from props here, like that. And let's return that, and we could actually return it implicitly, like that. Actually, I don't have probably formatter, which will do formatting from me. Format document with prettier. Okay. Document was formatted, and this functional component returns such JS6, and inside of this JS6 there is div with link.description and link.url, and it is exported as default export from this file. Okay, this is a sample React component that expects a link in its props. So here is a link which is part of the props object, which is actually argument with which we will call this link function when a component will be rendered. And it renders the link's description and URL like that, without any styling, without anything. Next, let's implement the component that renders a list of links. Again, in the components directory, go ahead and create link list.js file. Let's do that. Let's create link list.js file and insert following code. Let me grab it from here and paste here. So it is actually hard-coded list of links, yeah, array of links with different IDs, so just two different links, this one and this one. So first we will actually render this hard-coded list of links, and afterwards we will query server using Apollo client, and afterwards display actually dynamic links from the server. So here we map over links to render array. So map is array helper method, and here link will be a single element from the array, for example this object or this object, and we generate link component here. We export link from this file, and for each link component we send two props, key, which is link.id, and link. Key is required whenever you use map method, because each child component has to be unique in terms of React virtual DOM, and that's why it has to have a key property. And there is one more property, link, and here we pass actual link, and inside of link.js file we access description and URL of the link. like that. Okay, so that was done. Here we are using local mock data. That's what I just explained to you. So here is sample data, array of 2 objects for now, and we'll soon replace this with some actual data loaded from the server. To complete the setup, open up the GS and replace the current contents with the following. Let's go to up.js file. Why do we use here class instead of functional component? Okay, let's go to up.js file. Let's actually do following. I will not use class-based component because it is outdated, and there is no need for class-based component here. That's why let's keep it as functional component, and simply let's return link list like that. Return, let me remove that, return link list. And there is no need for logo.svg file. Let's remove it, and I'll remove it from the project itself. So logo.svg was removed, and in the up.js file I have to import link list. So import link list. I import it without any curly braces because it's default export from the link list file. So here is default export default link list. That's why let's import it from /components / link list like that. So it was imported, and here where we render it. And now we should already see it in our application. Cannot resolve. It is located in the same folder because up.js is in the components folder as well. So let's. Okay, so now I see 2 links. Of course, they are not formatted using CSS styles, but at least I see. Let's go to link.js. I see description of the link, and I see actual URL. So here is description, and here is the URL in parentheses. And there are 2 such URLs. Let me. If I modify it here, for example, let's go to this. Let's add 1 more link here. Probably I'll do it like that. So notice that IDs are unique, and they are used as keys when we map over those objects in the array. So ID 3, description. Again, let's add my website. Bogdan. Like that. URL. Let's save changes, and now it should appear here. All right, let's proceed. So we have statically displayed some URLs with descriptions. Writing the GraphQL query. Let's now load the actual links that are stored in the database. The first thing we need to do for this is define the GraphQL query we want to send to the API. Here is what it looks like. Feed ID, links ID created a description and URL. This one is similar to this query which we tried here in this interactive playground. We could now simply execute this query in a playground. Yes, we can. Why not? Let's execute it. That's what we get. So each link has ID, created a description and URL. And basically our mock data has similar fields: ID, description and URL. ID, description and URL. But created at is missing in our mock data, which we hard-coded, but is present, of course, in the database. Okay, we could now simply execute this query in the playground. We already did that. Queries with Apollo client. let's open up linklist.js and add the query to the top of the file. Let's open up linklist.js. Here it is. And now we have to import useQuery and GraphQL, shortly JQL, from the Apollo client. And afterwards we will create feed query JQL. Then between backticks we have to write actual query. Let's do that. Let's go to linked list. Here let's import useQuery and JQL from Apollo client. Here is feed query. It could be defined outside of this functional component, of course. So same query as we tried in interactive playground here. Next, instead of iterating over the hard-coded links to render array, pass the feed query document into useQuery and iterate over the returned links. Okay, so we have to call useQuery, and as argument here we have to pass feed query, which we defined here. So let's remove links to render. Let's get rid of it, and here we will call useQuery, and argument here will be feed query. Simple as that. Feed query. Wonderful. And now we should get a result from the server. Let's basically quickly try that. Let's go to our app. Links to render map is not a function, so it did not work. useQuery, GraphQL, Apollo client. Okay, probably we have to do something else. But do we have any logs in the front-end application? No logs for now. Okay, let's go back to tutorial. Let's take a moment to walk through what's happening with this new code. The feed query variable uses GraphQL, a library that uses tagged template literals. Yeah, in JavaScript there is a feature called tagged template literal, and we actually send this template literal to JQL, which is actually function, if I'm not mistaken, and it actually parses it and sends corresponding query. So this query document is then passed into the useQuery hook in the link list component. Const we have to do in following way. Data colon links to render. Let me try that. So link list. We have to iterate over data.feed.links. Let's do that. Okay, let's keep it data as an example, and here will be data dot. Let me go to interactive playground. So links here are available as data.feed.links, right? That's how we access it. Data.feed.links. Data.feed.links. And also, before iterating over links, we could check whether there is actually data or not. For that we could use AND operator. So if data is present, then we will iterate over data.feed.links and generate separate links on the web page. Let's save changes here. And yeah, now I see links from the database. At the moment there are 5 of them, and that's what we see in interactive playground here. If I add here count as well, I'll see that there are 5 links. Count. So 5 links are here. Great. So now we get actually data using GraphQL client in our front-end application. So the feed query variable uses, so I already explained that. This React hook, which we use here, it is use query, it is custom hook. It is simply a function which takes some arguments and returns some result. And this hook returns 3 items that are relevant for our purposes at this moment: loading, error, and data. Loading is true as long as the request is still ongoing and the response hasn't been received. And yeah, it is very useful because we could utilize such loading variable in order to show some spinner on the web page while data is loading by GraphQL client. Error, in case the request fails, then this field will contain information about what exactly went wrong. Data, this is actual data that was received from the server. This object. It has the links property, which represents a list of link elements. The injected props actually contain even more functionality. You can read more in the API overview. Okay, so 3 fields are present there: loading, error, and data. When the link list component initially renders, there won't be any information on the data variable. Of course, and that's why we added this quick check. If there is data, and only if it is present, we will iterate over data feed links. So for this reason, we need to check the data is truthy before trying to render any of the links that will come out of it. Once our GraphQL request, it is important, resolves with some data, the link list component will re-render and data will be truthy. And our links available here, yeah, as data.feed.links, will be rendered. So we will map over them. Recap that map is array helper method that iterates over existing array and creates brand new array. And in such case, we will actually create array of JS6 elements, and each will contain actual link component, where we will pass such props as key and link. So that's it. You should see the exact same screen as before. Alright, we completed this part. So here are 5 links from the database that we retrieved using GraphQL. And it was as easy as that. We defined feed query using template string tagged template literal, and we imported use query custom hook from the Apollo client and JQL, which actually parses such query. But what if I make mistake in this query? For example, add one more pair of curly braces like that and reload. Syntax error, expected name, found opening curly brace. And it was generated by what? It was generated by parse document function. Okay, so let me get back to this solution. Also, it is possible to execute query here directly in the Visual Studio Code, as I see. But I don't see any result here. Let's execute once again and don't see anything. Okay. So, here we call use query. It is a recap hook. And as argument here we pass feed query, which will be actual result of the call to JQL. And here we will get data, loading. Let's do following: loading. Let's also destructure here loading from the call to use query. And let's log to the console loading and see what is the value of the loading during life cycle of this component. Let's reload page. Let's open up developer tools, go to console, and yes, I see here loading first was true and afterwards false. Let's reload. So here is loading true when data is still loading by GraphQL Apollo client, and afterwards it becomes false. So loading false when data was already received. Great. So what's the declarative way for loading data with React and Apollo? Use a higher order component called GraphQL. No. Use fetch and putting the query in the body of the request. No. Using the use query hook and passing the GraphQL query document as an argument. Yeah, it is as simple as that. There is no need to utilize different libraries like Axios for making requests to backend server, or use fetch, for example, which is included in the web browser by default. So just use query hook and pass to it GraphQL query, and the rest will be done inside of it, and it will simply return the result from the server, so data, or error or loading. Sorry, not or. All of them will be returned: data, loading, and error, if any, of course. Otherwise, error will be empty. Go to next chapter. Creating links. There are two top-level operation types in GraphQL: queries and mutations, and we already know that. Using query we could get information, and using mutation we could perform some modifications of the data, like update, create, or delete. Queries are used when we want to read data. Mutations are used when we want to change data. In this section we'll learn how to send mutations with Apollo. Doing so is actually not that much different than sending queries and follows similar steps. Write the mutation as a JavaScript constant using the JQL parser function. Use the useMutation hook provided by Apollo client to send mutations to our GraphQL server. Simple as that. So here we will import also useMutation and call it with argument which will be actual mutation query. Read the result of the mutation. Okay, so let's prepare our React components. Let's create a new file called createlink.js in the components folder. Let's create createlink.js file, and here are contents for this file. Okay, so here is functional component called createlink. Here we use a built-in React hook called useState, and we will create actual form, yeah. And initially it will have such fields as description and URL. It is just an object, with two fields, description and URL. And there is also function set from state, which we could utilize in order to update the value of the form state. That's how changes of the state in React actually works. We have to call such function as set from state. And basically what we do here, we call useState, which returns actually array of two elements, and using the structural assignment syntax, const and in square brackets two variables, form state and set from state, we assign those two elements in the array which is returned by useState to different variables, form state and set from state. And afterwards we could utilize them underneath. So here is form HTML. In the onSubmit we create a callback function that prevents default behavior for such form. Then there is div with some classes. There is input inside, one more input. Alright, nothing special, and here is button which submits actual form. And when we change form, we call such functions as you see here in the onChange event handlers, And we call setFromState function, this one, and update from state object. That's the way how you could create controlled inputs in React. So this input is basically bound to the state of the application. So each time when you modify this input or this input, we modify value of the form state object. So here we destructure previous value of the form state and rewrite URL and set it to its target value, which is actually a value of this input. Yeah. And similarly, we update description here, description of the form state. And the form state has just two fields, description and URL. That's why there are two inputs, here and here. All right. So that's what we do here in this file. This file will be used in order to create actually new link. And of course, we will add here mutation that creates new post. Yeah. So this is standard setup for React component. So I explained to you what happens there. Writing the mutation. Our job now is to take the user input and send it as arguments in the GraphQL mutation. So we have to send mutation request to the GraphQL server. First, we need to define mutation in our JavaScript code and use the useMutation hook to fire the mutation. So in the create link file, in the same file where we just added this boilerplate code, we have to import useMutation and JQL parser from the Apollo client library, like that. Now we have to create actual mutation query and parse it using JQL. Let's do that underneath import statement. So here is mutation query, and $. Okay, so we didn't see $. Before, but probably it will be populated by values of those fields from the state, but I don't see now how it will happen. Okay, let's go on. So here is mutation called post mutation. It is just a local name, which is just locally significant for this client. It was not defined on the server, but actual mutation is here. So its type is post. We post new post. And here will be description of the post, URL. And we expect to get such fields in response from the server. ID, created at, URL, and description of the newly created post. Okay. Next, pass the create link mutation to the useMutation hook and pass in the data provided in the input fields as variables. Okay, so now I get what this $sign means. Actually, now here we will call useMutation hook, which we import from the Apollo client, and let's call it underneath this useState function call. So useMutation, and it expects first argument as actual query, which we defined here, mutation query, useMutation, create link mutation, and second argument will be variables, variables that we attach to useMutation function call, and using those variables it will automatically fill values for description and URL. Okay? And basically here we define type for description and URL. They must be strings. Create link, and here will be an object with variables. Here it is. Object with key variables, and it holds object with all variables that are needed in order to fill in this actual mutation request. So $sign inscription and $sign URL. That's where we define values for those fields. And notice that we take description and URL from the form state object, this one, which is state of our create link component. And inside of this form state variable, there is an object with two fields, description and URL. And that's how we access them using dot notation, from state.description and from state.url. Okay. And we next create variable called create link. But why it is create link? Where is mutation post URL description? So here is corresponding mutation, right? Where we could create new post with URL and description fields, and in response we get link, right? With ID, description, URL, posted by. But I don't get why we have to describe the structure here, create link variable. When we use the use mutation hook, we need to destructure out a function that can be used to call the mutation. That's what create link is in the code block above. Okay, so it is just a function that can be used to call mutation. So here we don't yet perform mutation, so we just create mutation. So fill mutation with necessary variables, and afterwards we have to call that mutation. Create link variable is here. We are now free to call the function whenever we need to, when the component renders. Okay, so let's I assume that this variable is always present as a result of the call to use mutation hook. So const create link use mutation. And here are two arguments. First one is create link mutation, that is a result of the parsing of such mutation query. And the second one is object which has, for example, variables, object with variables which will be used to fill in necessary fields in the mutation query. And it returns an array which has at least create link property. And using the structural assignment, we pull it out from this resulting array and create new variable called create link. And now we could call this create link function anytime when we want to create new link. And we could create different links during life cycle of the React component, right? React application. We could fill in form with URL and description multiple times. This variable will be updated multiple times, and each time when we will call create link, new post will be created, right? Okay. So make a call to create link in the onSubmit event on the form tag. So here is onSubmit function, which is called when you press the button here, when you press submit button. And each time when you do so, we will send the actual request to the backend server. And in order to do that, we have to call create link function. Simple as that. So we call it. Inside of this function, we already know that we have to populate variables depending on the values of the form state description and form state URL, and afterwards mutation request is sent to the backend server. Alright, so let's simply call create link in the onSubmit. And that's actually it, probably. We are now ready to check whether the mutations are working. Open up the JS file and change it up as follows. Create link. Let's So now in the app.js file, let's save changes in this file. And now in the app.js file, we will simply import create link from create link, like that. And now instead of rendering link list, we could return create link component, like that. Let's save changes, and actually we don't require a link list for now. And let's reload our application. It was actually restarted automatically, and here I see large form because I zoomed in on this web page. And here let's fill in description for new URL and actual URL. Which URL you would like me to enter here? I don't know. Let's Google. Google, and here will be https google.com, and let's submit this URL. Argument ID for data posted by connect ID must not be null. Please use undefined instead. Okay, I got an error. Let's check what is an issue here. Actually, I did everything as was needed. Let's actually, here I don't see any errors. Let me have a look at the developers console. So argument ID for data posted by connect.id must not be null. Okay, I probably understood where is an issue. So here in the so here is an input, submit. Let's go to network tab probably first, and let's have a look at that. Let's go to fetch XHR, add here again Google, and okay, submit. Here is actual request to the backend server, localhost 4000, this post request. Here is request payload. Where it is? I cleared it. Constructs an instance of Apollo error given in GraphQL error. So, operation name, post mutation, query, mutation, post mutation description, string. Okay, we actually send actual variables in request to the server, as you see here. Yeah, Dennis, I agree with you. When I record courses, I usually cut out all this troubleshooting stuff, but here I am not able to do that. Here we send description and URL, query, mutation, post mutation, description, string, URL. Let's have a look at the preview. So I got response from the server with errors. Internal server error, argument ID for data posted by connect ID must not be null. So I assume I have to also add some additional data in the request. And of course, I am not able to create new URL if I am not logged in, right? It means that in order to create a new URL, I have to add token in the header of the response of the request. But let's see what is written here in the tutorial. 2 input fields and a submit button. Okay. Enter some data, then click submit. You won't get any visual feedback in the UI, but let's see if the query actually worked by checking the current list of links in a playground. You can open playground here. Of course, if I open playground and run this request here, I'll still see that there are 5 links, right? A new link was not created due to error. Yeah, I see that I get actual response from the server, so server is still running. But in this tutorial, I expect to get actual URL. How to GraphQL.com, the best learning resource for GraphQL. Awesome, the mutation works, great job. So according to this tutorial, my mutation should work. But of course it did not work because I have to provide authorization header as I did, for example, here when I created new post, right? Let's try to perform same operation here in this interactive editor. So let me take this mutation. I'm not sure whether I'm able to copy it from here, where it is. Headers, view source, operation name mutation. Let me try to copy it from here. Paste here. No, it should be parsed somehow. Probably I could take parsed. Can I copy object? Operation name post mutation. No, it did not work because the format of this request is actually JSON, and it doesn't correspond to actual format of the query here in the editor. But I could do following mutation. Here will be post. Let's have a look at documentation for post. Post. Here I have to provide URL and description. Let's do that. URL. The string. How should I put string here? In double quotes or single quotes? Test URL. Probably double quotes, no? Okay. Test URL. And description. Sorry, description will be actually test URL. Description, test URL, and here will be test.com. And I expect to get ID and URL, for example. ID and URL, like that. And also let me add here posted by. Posted by. And here will be name of the author who posted this URL. And now, let me first remove this authorization header from here. And let me keep it, for example, here for reference. So I removed authorization header. And now let's send request here in the interactive editor. Argument ID for data posted by connect ID must not be null. Same error as I got here in the response. Of course, I am not allowed to perform mutation if I'm not logged in. And let me find where it is actually defined on the server. Server schema.graphql, type mutation, post, URL description. link. No, it is not defined here. New Apollo server, rec headers authorization. Okay, so I get user, so here we get user ID from the request. If there is a request and there is authorization in the headers. Okay. User ID. So I think that it is defined here in resolvers, and this error is generated here by one of the resolvers, which don't allow to resolve and to perform actual operation if there is no user ID that was retrieved from the token. And that's why if I add here token, let me grab it from here and insert back here like that and send same request, I'll see that post will be created, right? So it means that we require to add authorization to our front-end application, which is actually absent at the moment. And I don't know why in the tutorial this creation of the post comes before actual authentication of the user. It will not work without token. But how could we add token now to make it work faster? So create link, use mutation, probably use mutation options, mutation hook options. Let me try to follow. Use mutation, create link mutation options, mutation hook options, default context, operation variables. Use mutation. I assume that we have to send to add authorization header somewhere in the call to use mutation. Let me try to search for that in documentation. Use mutation authorization header. Okay. Apollo client, create HTTP link. So where we create a new Apollo client here? We created here, new Apollo client. And that's where we have to actually insert authorization header. Link, auth link concat, HTTP link, create HTTP link. Okay, let's set context. Let's import set context from Apollo client. So I am trying to fix issue with authentication now and insert manually token for specific user to local storage, and afterwards insert it into the authorization header in all requests which will be sent from the React application to the backend server. in order to fix this error which we see right now here. We're not able to submit URL because user was not authorized actually to do that. There is actually no user at all. And if I go to headers here, in the request headers, there is no authorization field, you see? So that's what I'm trying to fix right now. So set context was imported. Let me grab that from here. So new create HTTP link, underneath will be auth link, set context, headers, where is headers, here is the structural assignment, here is this rest operator, spread operator, which we use for headers object, and we add also authorization field, if token, bearer, and token, and we read token from the local storage, and there should be item called token. Okay, and here we have to take auth link object and concat to it HTTP link object, which we created here, where we specified URI, which points us to backend server. So let's auth link concat HTTP link here, and now we could save that, and let's create token in the local storage. Let's go to local storage. Where is local storage? Memory? No. Application. Application, storage, local storage. And let's add key called token, and let's take key which I used for successful operation, and this key I got as a response to login event of specific user, and I logged in as Bob, and the server returned me such bearer token. Let me take it and paste as value here in the local storage. All right, it is here, and let's. So local storage should not be cleaned. So application, if I refresh page, so yes, there is still token here, and now let's try the same description. Google.com, submit. I see nothing because form was not cleared. There is no such functionality in the application, but I don't see any error, and it's a good sign. And if I go to network, fetch XHR, basically let me submit. Actually, let me add one more link. Amazon.com. Let's submit. Here I see request. Response is 200 OK. Now I see authorization bearer token here. Yeah. And there is data in response with post ID, created ad, description, and URL. So it means that now link was created successfully. And I could check that here, for example, where I could query for links which are already present. So count is 8 at the moment. And at the very end, I see that there are links google.com and amazon.com with corresponding IDs and created ad. So that's how this tutorial should be fixed. So you have to also insert authorization token in the headers from the client to the server. And I did that in following way, as you see here. So when I create new Apollo client, I also add I concatenate auth link and HTTP link objects, and now this link object actually contains authorization property, which has bearer token string as a value. If we were able to successfully read token from the local storage. And for that we utilized a set context from Apollo client library. Alright, and again this was absent in this tutorial. And that's the response from the server. Okay. So here is a raw response and here is parsed response. And those fields which we get as a result of the mutation operation are defined in the create link query here. ID created at URL and description. ID created at description and URL. And also there is meta field which was added automatically, type name link, which is probably needed for GraphQL client purposes. Alright, let's proceed. So, which of the following statements is true? Only queries can be wrapped with GraphQL higher order components. When wrapping a component with a mutation using GraphQL, Apollo only injects the mutation function into the render prop function. Use mutation hook. Yes, probably this one. Yeah. So use mutation hook provided by Apollo client is used to send mutations to the GraphQL server. So let's go to next chapter, which is routing. So till now I see that in this tutorial there is a bit outdated version of the backend application, and it uses a little obsolete versions of the packages, and I needed to downgrade version of the Node.js, and now I'm using version 12.11.14, and with this version backend application works correctly. And also in previous chapter there was lack of instructions how to add authorization token into the header, otherwise new posts will not be created because server expects to see authorization token in the header. So routing. We will probably install React Router here in order to provide navigation between different pages. So let's add React Router DOM package. We will do that in the front end application. So let's go to, let me create one more terminal here. And I am inside of the Hacker News React Apollo folder. It is actually front end application. ls-la has packaged the JSON file here. And let's npm I React Router DOM. Create a header. Before moving on to configure the different routes for the app, we need to create a header component that will hold the navigation links. Create new file called header.js. Let's go to components and create new file new file header.js. And here are contents for this file. Let me copy them. So we import link from React Router DOM, which is still being installed. So here is functional component header. There are several divs with some classes applied to them. Recap that we added custom style sheet in the styles folder here, and it is index.css, and there is such style, for example, as F11, and that's that style which we see. No, we don't see it in the header, but we see PA1, flex, and probably those styles are present in this CSS which we added in the index.html file here. So this was added by us. So link to this Tachion's min CSS file. Okay. So here in the header, again, there are some divs. There is link to root URL and there is link to create /create URL, where I assume we will be able to create new links. Okay, so let's save changes in the header.js file. Export default header. The header component currently just renders two link components that can be used to navigate between link list and create link components. So one page will show us all available links and another will give us ability to create a new link, to submit new link, as we are doing that right now here on the main page. So package was installed. For some reason, Google Chrome again takes almost 100% of my CPU. So now less. Don't know what happens. And okay, so the header component currently just renders two link components. So question, how many hours do I code daily? I cannot say how many hours I code daily. I mostly spend time recording courses and editing videos. But when I need to create projects for my courses, of course, I spend much time coding, and it could be even full day, like for example today when I do this live stream. So again, my main job is to create content for you guys and learn, of course, much. And when I learn, of course, I code much as well. So here we see that this header component returns links, and the link will actually allow us to enable routing between different pages. So here is first link and here is second link, and text on those links will be new and submit. So here this link will lead us to root page, and this will lead us to /create page in the front end application. All right. Don't get confused by the other link component that is used here. I already explained to you what is that. It is imported from the React router DOM. The one that you are using in the header has nothing to do with link. Of course, link here is not any way bound to our link.js component that we defined here in the link.js file in the components folder. So this link is a component, and this link is an actual component from the React router DOM. And probably if you want to avoid any confusion, you could import link as router link here, right? And now replace all occurrences of link here with router link, like that. And now there will be no confusion. Set up routes. Let's configure different routes for the app in the project's root component app. Open the app.js and update it to include the header as well as link list and the create link components under different routes. So let me just grab this from here and go to app.js file and replace everything here. Okay, so here we import create link from the components header that we just created and link list. Create link will allow us to create a new link and to post it to the server. Header is header, which will be on the top of the page, where we will have two links to switch between two pages, root URL and /create URL. Link list is just a list of posts that we will retrieve using a query by Apollo client that will return us entire list of all links. And that's basically it. So header will be always present on the web page. And next, using switch, which we import from the React router DOM, we will allow actual switch between different routes. And inside of switch, there are two components called route. And route is obviously also imported from the React router DOM. And using route, you could specify actual paths to different pages and which components you want to render on corresponding pages. So on the root page, we will render link list component. And on the /create page, we will render create link component. All right? So that's how app.js file looks right now. And we should already see changes here. Switch is not exported from React router DOM. Probably I installed again more recent version that is expected by this tutorial. Let me take this error simply and go here. Yes, switch has been replaced with routes. So let's find all occurrences. No, how could I replace all occurrences? Which is a shortcut for that? Change all occurrences, routes, like that. And let me check version of the React router DOM which was added. It is React router DOM. Yeah, it is version 6. So in this recent version, this functionality was a bit updated, and now it is not switch, it is routes. Okay, so let's see whether it will work. So use href may be used only in the context of a router component. So it seems to me we have to render routes in some other way. Switch routes route. You also need to update route declaration. Path element. Okay, so we have to replace component with element. Okay, still doesn't work. Path, route. Okay, let's go to documentation of the React router DOM npm. Okay, React router. Import browser router as a route. So this is outdated documentation. This is v5, but I want to read v6. Of course, it is easier to install previous version, right? But I want to try to fix that first. React router is here. Read the docs. Installation. Do we have to import browser router? Okay, let's go to index.js file, and here let's import browser router from React router DOM, and let's wrap our React DOM.render into the higher order component browser router. And let's put everything here inside, like that. Comma should be here. Browser router, okay. And now routes and route will be imported from React router DOM in the app.js file. That's what we did. Routes, route path element, we fixed that. Okay, so let's see. Okay, now it works. Now I see header and two routes, new and submit, but I don't see any components rendered underneath. Functions are not valid as a React child. This may happen if you return a component instead of component from render. At routes. Okay, let's go to app.js file. Here I have to wrap linked list and make it as a component, like that, according to new approach. So create link, and here will be self-closing JSX tag. Let's save, and yeah, now it works and no errors. But why I still see true and false here, where I added a console log here? Let me remove it. Find folder console.log loading. Yeah, let me remove this console log from here. So here is our root page where we load all URLs from the database, and that's where I see last two added URLs. And let's go to submit page. Here is submit page. Let's submit one more URL. Facebook probably. I honestly don't use Facebook much. Facebook.com. Submit. It was submitted, but I don't see any result, and the form was not cleared, so this functionality is not there, but I will not spend time now to fix that. But if I go to new now, I still see previous list, but only if I refresh page, I'll see new post. So okay, we did not send a request for new links each time when a component is rendered. Let's go to link list. Data, use query, feed query. But let me see whether it is re-rendered or not. Re-render. If I navigate between those pages. Okay, re-render, but for some reason new request was not sent, even though there is a hook, use query. Strange, I assume that we have to get updated data here, because component is re-rendered. Probably there is an issue inside of the use query hook, I don't know, probably it works in such way. Let's submit one more URL. Test URL test2.com. Submit. New. Re-render. But test2 is absent here. Only if I hit refresh, I get test URL. Alright, let's proceed for now. Let me remove this console log from here. Okay, so we added that, and we now need to wrap the app with browser router. Okay, so I skipped this step and I did it already myself when I saw an error. So browser router should be imported from the React Router DOM, and you have to wrap Apollo provider inside of the browser router. So there is first higher order component, second, and inside of it we render finally our main app component. If we run the app again, we can now access two URLs, this one and this one. Okay. Implement navigation. To wrap up this section, we need to implement an automatic redirect from the create link component to the link list component after a mutation is performed. And again, you see that nothing regarding authentication and tokens, nothing. But it will not work without authentication, and we already verified it. So we have to send token. Okay. To do this, we can use the onCompleted function that is provided by Apollo when mutations are performed. So we can redirect user from create link page to link list page to root URL. We can use onCompleted function. Open create link.js file. Create link.js file. Okay. Use history from React Router DOM. Import use history from React Router DOM. Okay. Const create link use history. History use history. Where is create link? Let's add it here. Use history. It is actually also hook, custom hook that we use from the React Router DOM. It is not a built-in React hook. Create link variables description onCompleted history push /. So when mutation request is completed, this function will be called, this one, and using history push we are able to redirect actually user to one of the local pages, and we redirect him to root URL. Let's save changes. Okay. After the mutation completes, React Router will navigate back to the link list component that's accessible on the root route. With our current setup, we won't see the newly created link. We'll just redirect to the main route. Okay, so we could refresh the page to see the changes made. We'll see how to update data. Okay, yeah, they are aware of the fact that data was not updated, data on the link list, and a new link was not added. Use history is not exported from the React Router DOM. Okay. But how I imported it, use history. Okay, there is also probably change in that. Use navigate. Use navigate. Okay. So let's use navigate from React Router DOM. Use navigate and navigate to root URL. Navigate. So this change was also made in the version navigate here. Okay. So instead of importing use history, we import use navigate, then call it and assign the result of the call to navigate, and here we call navigate and pass a path as argument to it. So in such case we will redirect user to root URL in our application. Okay. Now let's try that quickly. So our application was loaded. Let's submit one more test. Okay. Okay, one more test. Test3.com. Yeah, I was redirected, but data is still old, yeah, and the new URL was not added here at the bottom, but at least I was successfully redirected, and that's what was requested by this tutorial here. Let's refresh page, and now I'll see one more test URL here at the end of the list. Wonderful. What's the role of the link component that you added in this chapter? It renders a link that was posted by a user. No. It lets you navigate to a different URL. It renders the input form for users to create new links. It links your root component with all its children. So link component we utilized here in the header, and it actually allows us to navigate to different pages, right? It lets you to navigate to different URLs. Yeah, that was correct. Go to next chapter. So, authentication, more mutations, and updating the store. Alright guys, I'll probably make a quick break now, and it will be a lunch break, so maybe 10-15 minutes, and let's assume 15 minutes. In 15 minutes I'll be back, and we will continue with remaining parts of this tutorial. See you.
said, anywhere you said, anywhere.
Alright guys, I'm back and let's continue our journey. And I'm at this step, authentication. And before that, I already coded this front-end React application, which consists of two different pages. Root page, where there is a list of already posted URLs, and each URL has also description. And there is submit page, which is located at the path /create. And here I am able to post a new URL for a particular user. And here is description for the link that we have to add, and there is URL on the second input. And submit actually submits such couple of text fields to backend, and basically a new URL is created in the database. Alright, let's continue. So now I'm here, authentication, at this step. And now in this section we'll see how to implement authentication with Apollo to provide sign-up and login features in our app. Basically, I already added such feature, but I, let's say, hard-coded it because it was necessary in order to create actual URL, because this feature is available only for authorized users, and this is blocked on the server if you don't provide corresponding token. That's why I added such functionality as defined in the index.js file here. And I read token from the local storage here inside of the set context function. There is a callback function, and set context is imported from the Apollo client. And I get token from the local storage, and this token is added into the headers field as authorization key. And next, auth link and HTTP link objects are combined together. HTTP link actually holds actual URL for our backend server. Now it is running locally at the local host port 4000. That's where it is running right now. Alright, so let's prepare components, and we will start by building a login component. Let's go to front-end application, and in the components folder, let's create a login.js file. And here are contents for this file. Let me grab all those contents. Probably I'll have to make some adjustments in this file because there is also use history, and we know that in the recent version of the React Router DOM, which is version 6, there was change, and now we have to import, where is it? In the header, I assume. Link use history. In the create link we used use navigate from the React Router DOM, and now we have to import it instead of use history, and here will be navigate instead of history. And if we want to point user to another route, where is .push here? Do we have okay, use history. So use history was not yet used here in this file, and instead of history push, we will call navigate with corresponding URL, like we did in the create link file. So where is it? Navigate. So like that, navigate to specific URL. So here is path where we should redirect user after specific action. Okay, so navigate was imported. Now here we create form state and set form state similarly as it was done in create link component here, but here we defined form state, and here we define also form state. Alright, but now this form state is an object with such fields as login, email, password, and name. And initially it will have such a value: login true, email empty, password empty, and name empty. Next, in this functional component that is called login, we return such div. Basically, it's not a good convention to return div like that, because it will create unnecessary element in the real DOM in the web browser. It is better to use just empty JS6 tag like that. It is called React fragment. In such case, React will not create additional HTML element in the actual DOM. Alright, so here we check whether there is already login in the form state, and if yes, we show here in the h4 login. Otherwise, if login is false, then sign up. Okay. So if not form state login, we show such input where we have to enter name. So placeholder is your name, like that. And one more input here that is not conditionally shown. It will be shown anytime. It is email. And anytime when user changes such input, we call setFromState and update the value of their form state variable and insert their email. Similarly, we update form state in other inputs, for example, in password input. So here is password, here is login. All right. So if form state.login, here we show on the button text need to create an account, question mark. Otherwise, we show already have an account, question mark. So that's how login.js component looks like. Let's quickly understand the structure of this new document. Actually, I already explained to you what it does. So in the onClick handler, in the submit button, we'll eventually call the appropriate mutations for these two actions. Now we don't have any mutations in this file. We have not defined them yet. Storing JVTs in local storage is not a safe approach to implement authentication on the front end. Because this tutorial is focused on the GraphQL, we want to keep things simple and therefore are using it here. You can read more about this topic here. Yeah, our backend server, when a user logs in or when new user creates an account, returns JVT token, and the sample token is here. And this token has to be included in the authorization header in all requests from the client which require actual authorization. And yes, it is not recommended to store JVTs in local storage, but for the sake of this application, we will do that. And basically, I already stored it in the local storage, and if I go now to application local storage, I will find token here. And this needed to be done before previous tutorials where this functionality for creation of the new URL was added. Because without token, it is not possible to create a new URL. So token is now present in the local storage. But of course, it should be written there by application, not manually, and removed by application if you need to remove it. Okay. Next, we also need to provide constants.js file that we use to define the key for the credentials that we are storing in the browser's local storage. Okay. So in the constants.js file, we will define key name for the key that will be stored in the local storage. So in src, create a new file called constants.js. Let's go to src and let's create here a new file, constants.js. And it will have a single export statement, export const auth token, and its value is auth token. Okay, with that component in place, we can add a new route to our routing setup. Open up the JS file. Where is our up.js file? And updated to include the new route. So here is new route / login, and it will utilize login component. Let me paste it here underneath this route, and of course, instead of component here we have to put element, because we utilize recent version of the React router DOM. So similarly as we did for other routes, here or here. Let's save. Add a link to the header to allow users to navigate to the login page. Alright, let's go to header, and here are 3 links. New, submit, and let's add one more link underneath, router link to login, and here will be login, right? Add a link to the header, open header.js and update render to look as follows. It's much more complicated than that I just modified. So it also adds conditional checks whether there is auth token available in the local storage by name auth token. And depending on that, we show different links in the header. So let me auth token link use history. Yeah, I'll need again to update history push calls. Okay, let me copy all of that and link to link but I want to keep actually router link. I don't want to rewrite it anytime when I modify this file. Let me check whether this logic is very complicated here or not. So okay, let me get back to my solution here. And now let me add missing logic. So let me import auth token from the constants file. Link is router link. And also we will import use navigate as we did for create link. Use navigate in order to navigate user to another page. Use navigate. Let's create navigate. Use navigate. And here instead of history push, we will actually call navigate. Let's get auth token from the local storage. Let's do that here. Okay. Return. No rep orange. Nothing changed here. Link to Hacker News. New. So new will be shown always. New, submit. But why it is called new, I don't get it. Why root URL is new? It is actually list of all posts, right? Let me name it all posts. And here we are able to submit new post, right? New all URLs probably, all links, let's say, all links. And here we will submit. Let me check up the JS file. So how it looked here. So at the root URL there was link list, Here is slash create link, link list, create link, okay, and login. Basically, I didn't import login from login, like that. Let's go back to header. There is also one new route slash tab, but we didn't create corresponding route. There is a link here to slash top, but there is no route here for slash top. Okay, but let me edit if they want to edit. So let's ML1. Let's add that here, like that. Okay, and here will be, of course, router link, because I import link as a router link to avoid any confusion with our link component. Search. There is one more link, search. Okay, let's add it as well. Okay, probably let me take this from here, this. Where is opening div for that? Okay, so there are different sections in the header now. This is first section and here is second section. Search. Okay, I already added. No, I didn't add the search here. So, okay, top. Now search. And afterwards slash create. And slash create should be visible only if there is auth token, and that's fully correct. And before we were not able to access it without auth token. So let me add it here, like that. And here we should close this div. Actually, like that. Div is closed. And now we have to open one more div and add this conditional logic here. So one more flex fixed auth token. Here will be a call to navigate. Don't get why here are backticks. Here should be single quotes, like that. So if we click logout, then we remove auth token from the local storage. That's fully reasonable. So if there is auth token, we show logout menu. If there is no auth token, then we show link to login page, /login. All right, let's save changes and see. Okay, link here and here should be router link. Let's save. Still link and link here. Router link. Okay. One more error. Link here and link here. So use push. No, we don't have any history push. All right, let's save. Now it looks good. Let's see how it looks here. Now here we see all links, which leads us to root URL, top. This route is actually absent. That's why we see nothing. We see only header. Submit new URL, and search. But submit should be visible only. Submit, search. We have to remove this submit from here. Alright. So submit should not be visible now. Submit will be visible only after login. If I go now to local storage, where I added key manually and rename it to auth underscore token, right? Auth token, and refresh view here. Auth token or auth token. Auth token from constants. It should be auth slash token. Auth slash token. Let's refresh. Yeah, and now I see search and submit, because now it found actual token in the local storage, and instead of login I see logout. Okay, and if I click logout, that key will be removed from the storage. But let me keep it there for now. And I should not forget that inside of the index.js file, I actually read such token from the storage as well. Let me rename it to auth token here. Probably same or similar functionality we will add now according to tutorial. Auth token. Auth token. Yeah, auth token. So let me keep auth token here as well, to be able to submit actual URLs now. So now I see that token is present, and I have functionality to submit new link. Let's proceed here. We first retrieve the auth token from local storage. If the auth token is not available, the submit button won't be rendered. That's what you just saw. Not just submit button. Submit menu item, not button. It looks like a button, yeah, but it is just menu item. Button is here, submit. We're also adding a second button to the right of the header. So this menu item. Here's what the ready component looks like. Okay, login. Let me actually remove from the local storage that record. Component login. Okay. And for that I could simply click logout, and it should remove that record from the local storage. Logout, yes, it removed. If I click login now, I'll see login page, this login component that we created. It is bound to /login path, yeah, and here we have to enter email address and save password and login, and click login actually, right? Okay, need to create an account. Perfect, we're all set to implement the authentication functionality using the authentication mutations. Sign up and login are two regular GraphQL mutations we can use in the same way as we did with create link mutation from before. Okay. Open login.js and add the following two definitions to the top of the file. Let me take those two definitions from mutations. Login.js. Let's add those mutations here. JQL, and of course we have to import that JQL from the import JQL from, what is the name of create link from Apollo client. Okay, so JQL was imported. Here is first mutation for sign up, and here we'll send email, password, and name. And for login, there is mutation which expects email and password, and all those fields will be filled using values from the form state object. So this object, which is initially defined with those properties: login, email, password, and name. And this object will be filled by using forms in the login route. Okay. So sign up mutation has 3 fields: email, password, and name, and login mutation has 2 fields: email and password. And this will call, actually, it will send login mutation, and this will send sign up mutation. And those mutations are enabled on the server here: sign up and login. So login expects email and password, and sign up expects email, password, and name. Wonderful. So mutations were created. Next, find the div element that has the class names flex and mt3 and replace it with the following. Where is flex mt3? So here is this div. Let me take this entire div and replace it. Let me take this entire section and replace, select it with this one. Login, sign up. Okay. On click from state login or sign up. So we have to create those variables, login and sign up. The on-click event on the login create account button uses a ternary operator to call one of 2 functions. Yeah, that's what I just said: login or sign up. As the names imply, these functions will run mutations. One moment. These functions will run mutations to log the user in or sign them up for a new account. Let's put in the use mutation hook to make these actions happen. So, use mutation hook is used here and here. Let's import it, because they don't say to import it. Of course, we have to do that. Use mutation. We import it from Apollo client. And now let's call use mutation twice. And here will be login mutation, and here will be sign up mutation. Okay. Let's call them here. No, we have to call them inside of the login component. Those variables could be defined here, but mutations have to be placed inside of the functional component here. So let me add those calls here. And yeah, history push has to be replaced with navigate. Navigate. Where is history push again? History push. Navigate. History push. Yeah, no more history push here. Navigate. But do we have navigate here? Yeah, we have navigate here. Auth token has to be imported also. I don't, by the way, see instructions here. Now I see that. So now I see at the end what we have to import actually. And let me import auth token from constants like that, auth token. And now I don't see any errors. So, but let me explain to you what actually happens here. So we import use mutation from Apollo client. Here we created two sign-up mutations, sign-up mutation and login mutation, using tag template strings. Here we actually call such function which parses such template string literal, which is actually defined here between backticks, here or here. Here. All right, so here we call sign up mutation, which is available here as we just seen. So sign up mutation, and also there is login mutation. And here are fields which are expected by those mutations. So sign up mutation and login mutation. And when we call use mutation here or here, it returns actually array which has such property as login for this function call or sign up. So login and sign up here correspond to those names of mutations here and here. Here we define which fields we expect from the server to be included in the response. So here or here. We just require to get token from the server, which is JVT token, which we should store somewhere, and we will store it in the local storage. And that's where we actually do that. When this mutation is completed, here we pass on completed key in this object, which is object with options like variables and onCompleted. It calls this callback function and sets actually auth token in the local storage, and it sets it to login.token. But where we actually write this token to login? Sign up, local storage, set item, sign up.token, login.token. It is available here as part of the response from the server. So login.token. So it is property of the login object. Same applies to this. So token here in this response from the server is property of the sign up object, this one, which we create using the structural assignment. So this use mutation again returns array where there is a sign up property. Okay, that's what is happening here. So we replaced use history with navigate. Use mutation JQL are imported from Apollo client. We can now create an account by providing name, email, and password. Let's test that. So auth token is not defined. So when I refresh, I see actual login page. Need to create an account. Okay, let's create account. Bogdan, your email address. Let's put my public email address. Password will be 123. Create an account. Okay. Account seems to me was created, and here I see that header was updated, and it seems that everything works correctly, and in the local storage auth token now has value which was just written there by application, so we didn't insert it manually. So when user registered, we actually got token in the response from the server, right? So I don't see previous responses here. Yeah, let's try log out. Let's log in my email address. password 123, and let me open developer tools and open up network tab and click login. Now I see request to localhost 4000 post. There is no authorization header because there was no token because I clicked logout. And now in the request payload, I sent login mutation, right? And there inside, there is email and password. So here they are, login and password. All right, and server responds back with object data, which contains login and token. And basically here, where we access login.token, we actually access token as property of the login. And it means that use mutation already parses this object, which has data key, and inside of it there is login key. It strips off data and returns this login here. And that's why we are able to access token of login, yeah? Okay. So now we should be able to submit new links. Let's say test 4. How many tests do I have? Test 3 is the latest one. Submit. Let's submit test 4. Test4.com. Submit. Let's refresh page and test 4 appeared here. Great. Now I am able to submit. And actually now I am able to get rid of the functionality which I added before. I mean, where I actually read auth token in the index.js file and inserted it to the headers in the authorization section. Because now application actually creates and destroys such tokens in the local storage. And that's why I don't need such functionality anymore, and I could get rid of it. Let me remove that, and let me remove this auth link. I don't need it anymore. And here will be simply HTTP link instead of auth link concat, like that. All right. So here will be just HTTP link. Great. Let's now retest quickly. Submit. Let's log out actually. Login. Your email address. My email address. 1, 2, 3. Login. Submit. Test 5. Test5.com. Submit. Yes, URL was submitted successfully. And it seems that everything works correctly, and the application now updates key in the local storage. And when user clicks logout, such key is deleted. Let's click logout. Let's go to storage, application, local storage, and there is no such key anymore. Let's log in again quickly. 1, 2, 3, login. And now this key should be present there. Application. Yes, auth token is now here. All right. All right. So we tested login functionality, and now we tested that the user is able to create new posts. We created new account. We logged in with registered account. We can verify that the new user is there by sending the user's query in the dev playground in the database project. But such query is not defined there, if I'm not mistaken, users. No, there is no such query, and we already discussed that before. Probably they mean something else here, because if I open docs and go to queries, there is just info and feed query here, and no user query. Okay, let's proceed. Configuring Apollo with the authentication token. Now that users are able to log in and obtain a token that authenticates them against the GraphQL server, we need to make sure that the token gets attached to all requests that are sent to the API. Probably I made a mistake that I removed this functionality from here because here we don't send actual authorization token. No, one moment. Use mutation, variables. Let me check. Login, use mutation on completed. No, here we only set item, and no, actually here we don't set it somewhere in headers, and that's but in my case it worked after I made changes in the index.js file, because React application did not restart after changes in the index.js file, because it does not monitor changes in the index.js file. But if I go to front-end application, stop it like that, and run it over npm start, let's refresh view here. So I am logged in, and let's now try to submit new URL. test6.com, submit. I should get an error, yeah. And I get this error because now headers don't contain actual authorization bearer token. And in this tutorial, only now, we need to configure Apollo with authentication token. It means that all what we did before, I mean in terms of submission of the new URL, is not supposed to work according to this tutorial. But it worked before because I had such functionality here which I just removed, like auth link and so on. Alright, so let's now try to follow this tutorial and configure Apollo with authentication token. Since all the API requests are actually created and sent by the Apollo client instance at the root of our app, yeah, that's where actually, okay, yeah, that's what I just removed from index.js file. Local storage, get item, auth link. Yeah, let me get back to it. Auth link, get set context, yeah. And here we import set context from Apollo client link context like that. That's what I already added to application back ago. Local storage, get item, auth token. Yeah, and here we could also get auth token from the constants, right, in order to access it here. Let's import it from constants. Import auth token from constants. So index.js is, yeah, near the constants file, so that's why this path is correct here. And instead of auth token, here will be auth token. Yeah, that's how we make Apollo attach authorization header in all requests, if this header is actually present in the local storage. Yeah, if it is present, then we attach authorization with such value, otherwise it will be empty string. Let's make it string like that to be consistent. Okay, and now let's restart our server, because again, as I just told you, hot reload doesn't work with changes in the index.js file. So npm start. Let me go back to instructions here. So we did that. Import context. This middleware will be invoked every time Apollo client sends a request to the server. Apollo links allow us to create middlewares that modify requests before they are sent to the server. Let's see how it works in our code. First, we get the authentication token from local storage, if it exists. That's what I explained to you here, and that's what happens on this line. After that, we return the headers to the context so HTTP link can read them. So, but where we actually concatenate that? That's where we concatenate auth link and HTTP link. So, again, we did that back ago. So here import auth token from constants. That's what we already just did, requiring authentication on the server side. The last thing we might do in this chapter is check how to ensure only authenticated users are able to post new links. And in this version of the backend application, it is already enabled, because before we were not able to push links. But now we are able to do that. test5.com, submit. So now we are able to do that. I submitted test5 twice, by the way. Do we have delete for the link, mutation, post? No, we are not able to post, mutation. We are not allowed by this definition of mutations to delete links. So only create new links and vote for links. That's why I will not be able to delete now this duplicate link. But anyway, let's keep it there. So, plus every link that's created by a post mutation should automatically set the user. Yeah, link which is created will have user attached to it in the posted by field. And that's what we already know. So if I search for links here and add here posted by and add here name, for example, I'll see also names of the users which posted corresponding link. So here is link posted by John Doe. If I scroll down here, can I add here last two or last five? No. So here I see that this link was posted by Bogdan. So posted by. And this functionality is already present actually on the server. So that's how it is implemented. We don't have to modify that. So it is in the mutation.js. Mutation.js in the server src resolvers. So that's where we create new link. Prisma link create. Here is data for new link, and here is posted by. And here we attach user, which we find, I assume, that's what connect here means, by ID. And user ID we take from the context here. Okay. In this code block, we are extracting the user ID from the context. That's what I just explained to you. The user ID is placed on context by extracting it from the authorization header. Post, context, but where do we actually call this mutation? mutation context user ID is present in the context. So user ID. Yeah, that's where we get user ID from the rec headers authorization. And there is a separate function which allows us to decode corresponding JVT token and get user ID out of it. And we could actually try following. We could take this JVT token from here, go to JVT decode, and try to decode it ourselves. So here is encoded. Let's paste this. And here I see user ID, algorithm and type of the algorithm which was used to create such JVT token. But here is user ID, and that's what is extracted by the server from the rec headers authorization. All right? And afterwards, it is passed as context to mutation function, this one. All right. So let's go on. Now we are able to post new links, and we were able to do so before as well. And that's it for this authentication section. How are HTTP requests sent by Apollo client authenticated? So the Apollo client needs to be instantiated with authentication token by attaching authentication token to the request with dedicated Apollo link middleware. Apollo client exposes an extra. No, Apollo client has nothing to do. Probably this one. Yeah. By attaching an authentication token to the request with dedicated Apollo link middleware. And this middleware is defined actually here, and it is set context. Yeah. So we insert authorization field in the headers, and its value is bearer plus token, which we read from the local storage, like that. All right, let's go on to next chapter. More mutations and updating the store. The next piece of functionality we'll implement is the voting feature. Authenticated users are allowed to submit a vote for a link, and we actually tested that before in this playground. The most upvoted links will later be displayed on a separate route here top, which we basically created in the header component, but we have not yet created a corresponding route for corresponding component for this route /top. That's why it is empty for now. Okay, preparing React components, open link.js file and update return JS6 to look like that. So where is our link? Here is link, and here we have link description and link URL only. That's what is displayed here. Link description and link URL. Very simple. And now here we have to modify this return statement and also add information about length of the votes posted by name, if it is present, or if it is absent, there will be unknown. Time difference for date. There is a function which is where. Probably we'll create it later. Okay, let's open link.js and update returned JS6. Okay, let me grab this entire const from here and replace it like that. Also, I have to links per page. It should be in the constants, I assume. Auth token. Let's import auth token from constants. And this will be added probably later. And let's destructure link from the props as we did before. Okay, so now we check also whether there is auth token, and we read it from the local storage in this link.js file. Honestly, it's not a good practice to read from local storage in multiple places. better to read it only once and place it into the state of entire React application, or into the state of main component, for example, auth component, or create separate context for that and use a hook which is called use context. But yeah, in this application it is done like that. I will not refactor that in order to avoid very lengthy tutorial today. But please avoid reading from local storage in different places. So it's not a good practice. Alright, so that was added. We are already preparing a link component to render number of votes for each link and the name of the user that posted it. So number of votes is located here as property of the votes object, this length property. So link votes length, it is JavaScript, and here is simply string votes by, and here will be name of the user which posted corresponding URL. Notice that we are also using function called time difference for date that gets passed the created at information for each link. The function will take timestamp and convert it to a string that's more user-friendly, for example, 3 hours ago. Go ahead and implement such function, and we will create it in the utils.js file. Let's create such file in the src folder. Let's go there, so new file, utils.js, and here are contents for this file. Let me copy it, paste here. So time difference function. I will not dive too deep into this function, but we assume that it will do its job and convert less than 1 minute ago, or min ago, yeah, a corresponding amount of minutes or hours here, or days or months, or years even. So, and here, so time difference function is defined here, and there is time difference for date function, which actually takes date as a parameter, and it actually calls time difference function, and it passes to it now, which is current time. We call new date and get time here, and you could try what we get when we call such function in the console, for example, here. So it is time in milliseconds since unique epoch. And yeah, so now and updated, and here we call time difference and return result of that function call. And now we are able to import this time difference for date function